Hello, everyone. So we have some more people coming in the waiting room. I'm trying to admit everyone while doing an intro as well. Okay. So it's 10:01 and I think I can just start by saying good morning or good afternoon or good night to everyone who is in a lot of different places. Or welcome to the first data science summer school organized by Hertie School Data Science Lab and Data and Methodology Center at the Scripps Cluster of Excellence. And I would like to thank our founders, the Scripps and the Stifterverband, for their generous support that made this summer school make it happen. And I'm extremely happy to see all you here today, both on Zoom and the parallel streaming session on YouTube. I would like to note a couple organizational and technical details. In the Zoom meeting, you're all muted and have your cameras off upon entrance. Please do not unmute yourself nor turn the videos on unless you have a question. If you have a question, please raise your hand using the raise your hand button on Zoom, or you can leave your question in the chat and we will handle the question in the chat, or we will give you like a time to speak whenever there's going to be a convenient moment if you raise your hand. If you are on YouTube, you can leave a question in the live chat and we will try to respond as soon as possible. I should also remind you all that the Zoom session is being recorded, and I will thank you all in advance for following the rules. And I'm super happy to say that we were starting our first workshop in this summer school workshop series. And this is an introduction to R programming. And let me introduce you Fabio Votta, who is going to be our instructor today. Fabio is a PhD student in political communication at the University of Amsterdam. He's a big R programming advocate and is very passionate about reproducible open science. And Fabio, the floor is yours. You can share your screen now, and let's get it started.
All right. Hello, everyone. Welcome to this workshop. I'm really excited to be introducing you to R, to the good message of R. When I'm looking here up on the right, that's where my Zoom screen is, so don't worry that I'm not looking directly into the camera. But yeah, I'll start by just sharing my screen and jump right into my or into our workshop. So this is going to be a fun intro to R programming. I tried my best to make it fun because I know that working with R can be a bit difficult sometimes. Learning R, the learning curve can be somewhat high sometimes. It was certainly for me. And so for me, the most important thing when learning R is to have fun and kind of learn new skills that really enable us to do something new and exciting. So if you are interested in following along with the slides are basically the same as we're going to have in our script later. On the lower left, there is a link to these slides here. You can have them for your reference, but everything will be ultimately in our Google Colab script. All right. So who am I? Olga already said a few words about me. I'm a friendly neighborhood R instructor. I'm doing my PhD in political communication. It was already mentioned. I could say that my background is not in programming or anything like that. I actually studied for my bachelor and master's social sciences, and I got introduced into R and the more data science stuff via, we're just learning statistics, and I found out there's a different way to do statistics. We were using SPSS at the time, and I found out there was a different way, and I found it really interesting. And I just tried it out for a long time until I was able to say that I understand what's going on in R. But ultimately, I became very passionate about it, and I'm pretty much using it every day, which is not something I would have thought that I do when I first learned it. In my private life, I really like to travel. Of course, this is not really possible at the moment due to a pandemic that is currently raging. You might have heard about it. This is an odd point, I guess, to include in an intro slide about yourself, but I really enjoy making R memes. I have a page on Twitter. Maybe you've seen it or not. I'll ping it later. And yeah, I just enjoy just a real geek when it comes to R, and you'll probably notice that along the way as well. Okay, so one thing I want to emphasize, and I already kind of mentioned this before, is that it's kind of normal, unfortunately, to struggle at first. And I struggled a lot. I want to kind of acknowledge that, just if something, you don't understand something at first, or you're like, oh, this is really confusing, right? It doesn't mean there's anything wrong with you, right? It is sometimes rather complicated and not intuitive if you don't know any other programming languages. So I want to kind of offer a word of encouragement that even if it seems like a rainy day today, with R, and it's kind of like a relationship that has its ups and downs, and certainly also for me still, I kind of get frustrated. But why does it get better? I can tell you because R has a really awesome inclusive community, and there are always ways to help. That's how I was able to learn it, to be honest, is just listening to the great community. Mostly, personally, I'm guilty of being a lot on Twitter, and there's a really great community there. But also just there's a very active blogosphere, which kind of teach people how to use R, and they have examples, and it's a really great environment to be learning it, just simply, by people who are so nice and share what they've created. And that kind of made me want to be the person as well that shares what they know, so they can benefit from that, right? It's kind of like a chain of goodwill, if you want to say that. All right, so what are we going to do today? The very first thing I'm going to do is I'm going to tell you a little bit about like what R is and why you should learn it. Then we're actually going to jump into the R basics, and this we're going to do in the Google Colab environment, where everyone will have the same environment to be working in. And here, when we teach the R basics, we're going to go into operators. There's logical and mathematical ones. I'm going to talk about R objects, functions. We're going to have some exercises where you can try out some of the things you've learned so far on your own. And then I'm going to teach a little bit about data frames. Then we're going to have a break at noon. It's probably going to be 15 minutes, depending on how tired you are and how tired I am after hearing so much about the R basics. But then we're going to start into actual data manipulation. So we're going to learn about the Tidyverse and its friends. It's going to be a few packages that I'm going to talk about. And at the end, there's going to be more exercises. And at the very end, you can ask me a few questions, general questions about where to go next, or my favorite color, whatever you think is most important. No, probably that not. Okay, so don't worry if anything here doesn't tell you anything yet. We'll get to it, right? So don't worry about that yet. All right, so what is R? R is a statistical programming language, which is developed for data analysis and visualization, right? So what does that mean, right? So there's programming languages. Okay, you might have heard about that. What is a statistical programming language? Well, it means that it's been primarily created with the idea in mind that you want to do some statistical analysis of it, right? There's other programming languages like Python, which can also do that, right? But they're not primarily kind of created for that. And R has kind of like comes packaged with a lot of functions already that allow you to do kind of statistical methods and other things. And I would also say that programming is, even though it's a statistical programming language, I would say that it can still do anything that, for example, Python can do, but its focus is on the statistical side of it, right? I would also say that R is really the kind of data science environment. Some people would agree or disagree with me that, and there's a lot of opinions on this. I would say R is the best suitcase for data science, but of course it never hurts to also know other languages, right? And you hear a lot of opinionated or like biased, I would say, things about R about me, just because like that's like what I'm working in mostly, right? And there's gonna be some Python stuff in this workshop, or not in this workshop, but during this entire summer school as well. So you Python nerds will also have something. So what is RStudio? Sometimes it's confused with R. RStudio is simply an IDE, which means an integrated development environment. I said simply, but if that doesn't tell anyone anything, if you haven't heard about what it is, it's just basically an interface. It's a software program on your computer, and it allows us to access R, right? So we can write R code, we can save it in files, and just open the files again there. And it provides things like syntax highlighting and auto-completion, so it really makes coding a bit easier. But it has to be physically on your computer for it to work. And we'll talk in a second about like why it might be difficult for a workshop like this. But first, we're going to talk about why we should learn R. I already mentioned this, but the R community is amazing. So maybe you've seen it, maybe you haven't, but there's a really great community on Twitter, but it's not just Twitter, it's just all over the place. There's so many great people. They're always welcoming. There's a lot of measures for inclusivity. There is the R Ladies, which really tries their best to kind of include more underrepresented groups. And there's so much open space to really feel welcome, also as a beginner, right? There's no one really that judges you for not knowing anything. And it's such a great and welcoming space. And I'm repeating myself, so I'll stop faulting about this. But I would also say that what's really great about R is that data wrangling is accessible and fun. So you might have heard about the Tidyverse. We shall talk about this in this workshop. It really enabled for me to understand what's going on with my data. Before, I didn't know Tidyverse from the very start, but I would say learning about this really enhanced like how I approach data and R in its totality, and it really helped me break through, I would say, and understand data better. The next thing is there's an outstanding repertoire of statistical and computational methods. So here on the right, you can see the Easy Stats package works, which has so many great packages to conduct a statistical analysis, to visualize them, and to just generally, everything you can imagine really about statistical analysis. And its name is its program, Easy Stats. It just aims to make it all easy, and it's great. Because it should be easy. It should be as easy and accessible as possible, and I really like that when it happens. All right. I would also say it integrates well with other programming languages, because there is a package in R called Reticulate, which actually integrates Python into R, right? And it seems a bit awkward, like why would you do that? But it actually works fairly well. And I think that's a huge upside in my point, because I want to use R. So I can just load in Reticulate and execute whatever Python code in the backend, of course. It'll still execute Python code, but you'll write R code. And that's something that's a plus for me, because that's the main language I'm using. And you might don't need to know much more than just R, but of course it's always good to know other languages as well. And of course, the big plus is the beautiful data visualization, which is mainly conducted with a package called ggplot2. Here on the right is a visualization of some penguin research data, which I find really amazing. And this is completely written in R, in a coding language. And I find it always kind of fascinating what things you can do that are physically pleasing, but just writing text, right? It's kind of like an interesting conversion from text to something pleasing that is pleasing to the eye. All right. So mainly in this workshop, we'll be using Google Colab. So what is Google Colab? It's a Jupyter notebook that is hosted online. And it's kind of the easiest way to describe it. It's like a Google Docs for code, right? So it allows you to simultaneously also edit the document. We're not going to do this here. You're going to have your own versions of this document. But the upside is, excuse me, the upside is you don't need to install R or RStudio on your computer, right? So I've done a couple of these workshops before, always in person, not online, but if you do an intro to R and you have to set up all the stuff around installing and so on, everyone's going to be like, what's actually going on? I don't have it installed. It's terrible for workshops. So we're going to use this that's already comes already prepackaged. You just have to execute the code. It just works. And as I said, I want to make it as smooth as possible for you. The downsides of using this approach, though, is that you will have to set up R and RStudio on your own computer at the end. Right, so if you actually want to use it and use it as it's kind of intended to be, then you should probably also have it on your computer. All right, so I would say we can jump right into Google Colab. And we can do that via this link that I put here. And I'm hoping that someone can also share that in chat. I don't have my chat open. Well, that's, I see. If I share my screen, my chat disappears. Okay, so I can't see the chat, but I think it's been posted, hopefully, yeah. All right. So I'm gonna click on this. Actually, I should go out of my, yeah, I should go out of the full screen, not click on this, whatever that is. Sorry. Ta-da. Okay. All right. So let's move the full screen. Now I feel like a boomer. Do you work? No. Oh, okay. Now works. Sorry. Oh, it's just like a, okay, dynamic. I see. Well, that's fine. That works as well. Okay, welcome to Google Colab. Sorry about this introductory problems. Okay, so this is the environment in which we'll be using a lot of our code. So beginning is just some basic description again. And Google Colab mainly consists of two kind of types of cells, right? So there's a text cell, which doesn't, text cells can kind of include images or text. And then there's also code cells. I'll just create one. So if here you can create a text cell, you can say, hello, write some text, and then it'll actually add it. But we don't need this. We can delete this with this trash can here. We can also add some code, and this code chunk actually runs R. Right. So one thing that coders always do, and we'll do this here, just is we'll print out "Hello World" to prove that this is R, or this is at least working. And you can, if you're already on here, you can also try this yourself. Just click on this plus code and then do print "Hello World," because that's kind of like it's a thing to do that in coding languages. When you first do this, you'll notice it'll take a little bit, just because it loads R in the beginning. Afterwards, it should load a bit quicker, right? So we print out "Hello World" and we have it here. And actually, when I said to prove it's R, I lied a bit, because this is actually the exactly same function in Python. So if you click print "Hello World" in Python, it'll also do that. But trust me, this is R, and we'll see that later as well. Okay, we can delete this, and yeah, all right. So I'm gonna quickly go on my slides again. I'm gonna show you one more thing. We're going to talk about math operators with my slides, and then we're going to actually work in Google Colab. And actually, the slides will have everything that's also in the Google Colab itself, but it's good to be like more interactive, so you can also like follow along as I'm doing the things. But let's start by talking about math operators in R. So at its core, R is just a fancy calculator, right? So it can just do all kinds of calculations. And here's a list of some calculations it can do, but it can do more than that. But you'll recognize these, you should recognize these probably. So there is addition is a plus, subtraction is a minus, multiplication is a star, division is a slash, and exponentiate is, I always forget the name, but in French it's accent circonflexe, but it's like uppercase thing. And then with that you can exponentiate. So if we were to do addition, we could just do 15 plus 5. And if you run that code, then that gives us a 20, right? Makes sense. And if we were to mix operators, do something a bit more fancy, I suppose, then we could do also with brackets, right? They work the same as in your calculator. First calculate this, 15 plus 5, and calculate this within the brackets, 2 times 5, and then divide. And if my math is not wrong, it should be 2. It is in fact 2. And right, So, but just using kind of adding up numbers for no reason is no fun, right? So that's why I've kind of created or came up with a data set that we can use kind of during this first moment of learning R. So I really like animals. You might like them too. And that's where we're going to use a data set about animals. And in fact, I chose a data set called Animal Aging and Longevity Database. It's created by a lab called the Jon Snow Lab, not related to the Game of Thrones character, I assume. And it provides data of over 4,200 animals, and it kind of has age about, it has information about the age of maturity, gestation or incubation periods, but also the longevity. So like how long do those animals live? And I chose this because I want to do something like a fun calculation that is not really that scientific, but it's kind of fun to do and people like to do it, is wanting to know how old an animal is in human years, right? So I have that calculation. There's a lot of like folklore about like how do you actually do that, right? So for dogs, you've heard like 1 year is 7 years in human years and so on. And there's no like really good actual scientific way to do it. Trust me, I've investigated this for that and spent too much time thinking about like how can I reasonably show this to you without like telling you too much that isn't true or not really scientifically provable. But I came up with a way that is fairly simple. It's not perfect, but it's kind of a normalization of the two stats, so you can find out how old the animal is in human years. So very short, easy formula. You divide the maximum lifespan of a human by a maximum lifespan of a non-human animal, and then you get the animal to human years ratio. And if you multiply that with the amount of years that an animal lived, you should roughly get how old that animal is in human years, right? Roughly, I'd say. So it's much more complicated in reality. If you're interested in that, you can later click on this link in the slides. There's going to be some stuff that it's like actually not linear, right? Not every year is the same for an animal and so on. You can go on into that. All right. The data set looks like this. This is actually just a snippet of it. But on the left, you'll have the name of the animal, the common name. And on the right, you'll have the maximum lifespan, right? For humans, it's actually interesting to know the maximum living human was a French woman, and she lived 122 years, which is quite a lot, of course. And keep in mind, these are maximum lifespans, right? These are the maximum observed lifespans that an animal ever had, right? So some of these numbers are quite high. For example, I've never seen a cat that was 30, but that's the maximum observed living lifespan for a cat. All right. So I think, yeah, we're going to run this in Google Colab now. So you go out here. All right. So if you have this open for you, you should scroll down to dog to human years, because that was what we want to calculate. So as we remember, our formula for calculating dog to human years, animal to human years is dividing the maximum human lifespan by the maximum animal lifespan. And if you want to do dog to human years, we first take the maximum lifespan of a human and divide that by the maximum lifespan of a dog. And that should give us 5.1. So for every year that a dog ages, they age 5.1 years in human years, roughly, right? So how old is a 15-year-old dog in human years? If we just use this ratio and execute the code, then we get 76.5, which is quite old, of course, for a dog, and 15 years is quite old for a dog. So I kind of play around with this, so like roughly it translates well. By the way, I should mention, to execute code, you can click on this little play button here, but you can also click Control Enter, and it'll just run the code as well. So there's two ways to do it. And if you just don't see me click on it, but I just run it, that's why, because I'm using Control Enter. Okay. So far so good. And we can also, of course, use any kind of operators as we did before. And feel free, as I'm kind of like explaining more stuff about it, just like trying out a different number, right? Like for cats, we remember it was 30. If we do that, we have for every human year, a cat ages 4 years in human years. Okay, let's leave it at the dogs one. Okay, so now we're going to talk about our objects. And you can think of our object as saving information within R, right? So we have those numbers, and it's kind of tedious to like all juggle them around as we did right now. We have to copy paste them from one thing to the other. And kind of to simplify the process is our objects. And we can sort of save that to our working environment by, or we can save it to our work environment and also recall them later with the name that we give it to them. And we can create those objects by using the assignment operator, which looks like this. So it's just an opening or greater than and a minus. And we have a name. So for example, human lifespan. And we assign this number with this symbol to human lifespan, or we assign this number to dog lifespan, right? There's also a way to assign with equal signs, but equal signs are not that well seen in some areas of our users, I would say. And it's also kind of recommended by the Tidyverse style guide to use the arrow for assignment, right? So yeah, so if we just execute this code, it'll save our numbers within those objects. And if we now run just the object itself, it'll have the numbers stored in them, right? Same with dog lifespan. I'll run this, then it'll have the 24 saved within the object. Now we can perform the sum calculations as before, but we can actually use the objects rather than the numbers, right? Which is more legible as well, right? So again, we divide the human lifespan by the dog lifespan, and then assign the result of that into a new object called dogs to human. And this dogs to human object has the ratio between dogs and humans, right? And we can also just use numbers in combination with those objects, right? Which is to say 15 times dogs to human, and we should get the same result earlier, right? Easy stuff. Now we could also do the same for cat to human years. And maybe you just want to try this by yourself. So you should hopefully have Google Colab open. Try to just use the assignment arrow and yeah, calculate the cat to human years and just do a 15-year-old cat, just to compare how old a 15-year-old cat would be to a 15-year-old dog. And I'll just give you 2 minutes because that should be fairly easy. And you can also like cheat by looking at like how actually it works. All right, so go at it.
Fabio?
Yeah.
Question, while people are doing an exercise, we have a good question, I think, in the YouTube chat. Is there a difference between objects and variables? And is our object is some sort of like a memory button on a calculator? You can clarify that.
Yes, very good question. And actually something that I should have clarified. A variable and object I use interchangeably in R. So in fact, it is the same thing, or the same thing as I use it. So variable is just something that can change, right? It's dynamic. You can put in anything you want, like in mathematics. A variable is also just a number, right? For example, or stands in for a number. And you can also imagine that. And the memory is actually also a really good comparison as well. Yeah, it's kind of like that, right? It just stores the numbers somewhere in the computer, right? And then you can later recall it by some name that you type in. Actually, I don't really remember how the memory button works in a calculator because I haven't touched one in a while because I have R. No, just a joke. But I haven't touched a calculator in a while. But If you can call it by its name in a memory, yes, that would be similar, right? But you can think of it that way if it helps you. Okay, so I think this should be enough. We don't want to spend too much time on this because this should be fairly simple. So what I like to do is be lazy and just copy paste what we have up here and just rename it because we already have a lot of it written. And you'll notice that also along this workshop, coders are often very lazy. So they just like to copy paste things and then change it as they like it, as they need it. So I'm going to type in 30 because if you check the table again, that was the maximum lifespan of the cat. And we already have assigned to human years because we went through this, so we don't have to do it again. And so we can calculate the ratio. We first need a human lifespan. Oh, and by the way, this is auto completion. So also Google Colab allows to do auto completion. So you do this divided by the cat lifespan, of course, and then we have the cats to humans. Assign this to a new object. Actually, I'll do this in one thing as well. Cats to humans. Just click enter if this appears, right? So it'll auto complete to that. And to 15, and this should be 61.25. Hopefully, you also were able to deduce that because that should be fairly simple. But if not, of course, definitely comment with questions. Is it possible to delete the link between the word and number and redo it? You mean the underscore? Yes, you can definitely do that, but we'll get into a moment like why I'm using this and not something else. But this should also work, right? Well, not, I mean, we have to of course assign it to this name, right? But there's nothing special about the underscores, right? And actually this leads me really well to my next point, which is a note on naming stuff, right? So there's a fun little quote I like to throw around here, which is, there are only two hard things in computer science: cage invalidation and naming things. Cage invalidation, I don't even know what that is, and that's not really that important. But I find it funny that it's like next to naming things. So there's many ways to write code, and like different languages have their own like kind of conventions. But we, or like using the Tidyverse style guide, we often use underscore snake case or lowercase snake case. So what is that? What that means is we're going to have lowercase letters, and we have the link between the words will be an underscore, basically. We can also do kind of, it's also possible like camel case is always, first one is low and the next one is upper and so on. We're not going to deal with those kind of things. We're just going to use snake case. But technically, you could use whatever kind of word you want, right? We could name this, let's name this the weirdest thing you can imagine. Lol, the what? I don't know. That just came to my mind. And you can execute that, right? So it doesn't matter how we name it. And there's a couple of rules, like there's a couple of things you couldn't do, I think. But like for letters, everything should work. All right, we're not going to do that though. All right, so I already mentioned that. So animal lifespan, that's a recommended way to write it. Not recommended would be all uppercase for words or using dots. That's extremely not well seen because a dot is a special character and can mean something else in other languages as well. All right, let's get to the logical operators. So there are more operators, not just math operators, but also logical operators. And these typically evaluate to true or false. So these are also sometimes called Boolean variables, if you heard of that maybe. But before we jump into those logical operators, first let's assign a few more objects so we can kind of compare the lifespans of these animals to each other. And create some logical tests. So we're going to execute this. So it is important to execute before. We have a bunch of new lifespans to work with. And first logical operator I'm going to talk about is the equals sign, which just is basically asking the question, is this object the same as the other object? Logical, categorical, I wouldn't necessarily say it that way. It just means it's because categorical mean it can multiple characters, right? I would rather say it's binary, right? It's true or false. All right, so let's try it out. Let's try to compare the line lifespan to a boar lifespan. If you look up here, there should be 27, and a boar lifespan is 27 as well. So this should evaluate to true, and it does, right? So, and this is a special like kind of variable called a logical variable. It does not make a difference to include a mathematical operator. So you can actually just combine them together. The space is not important, but it looks nicer. All right, and just feel free to try these things out, right? You can definitely just try them all on your own as you have this. So there's another new operator called not equal, and you do a exclamation mark and equal. And oftentimes exclamation mark in programming language in general mean negation, right? So it kind of changes the meaning of it. So that's a good thing to remember in general, that the exclamation mark means negation. So if you have the same test, but say the line lifespan does not equal to a boar lifespan, right? And we know that this is to be false because they are the same. This should give us back false, and it does, right? Very simple. All right, so the next logical operator we're going to learn is greater than or smaller than. So if you want to know whether the human lifespan is bigger than the fly lifespan, I think we can deduce that without looking it up. We can say that's true, right? I think the fly lifespan, the maximum was like 0.3 days, years. Sorry, so that would be like more than 3 months. So we can have greater than, but we can have also smaller than. Oh yeah, it says here 0.3. I want to know whether an alligator lives shorter than a mouse, right? So that's the question it's asking, because it goes towards the mouse, right? The crocodile, that's how we learned in school, but actually it goes the other way around, right? And this is a false statement, right? The mouse is not older than, or does not have a longer lifespan than the alligator, and of course that's a false statement. We can also use greater or equals or smaller or equals, and they look like this, right? So this is greater or equals. Just put an equal sign behind that, right? So this should evaluate to true, because 22 is of course bigger than 20, but also 20 itself will evaluate to true because it's also the same, right? All right. Okay, so we come to combining logical operators. So there's multiple functions, but the two most important ones are and or. And is kind of self-explanatory. It's just the and symbol, and the bar is or. So this bar, you have to look it up on some computers because it's kind of different sometimes. But if you're lazy, and it's okay to be lazy in coding, you just copy paste the symbol from here, and then you can put it in somewhere. All right. Right. So if you want to combine logical operators, we can test multiple statements at once, right? So this evaluation here tests whether the alligator lifespan is longer than a mouse lifespan. This should be true. And a fly lifespan is bigger than a mouse lifespan. This should be false, right? The and statement makes it so that both of these statements have to be true for it to be entirely true, right? And it's not the case. It's false, because this part evaluates it true, but this part does not. If we use an or symbol, though, this can become true because we have either this is true or this is true, right? So in this case, this should evaluate it true. And it will in a second. All right, let's get to vectors. So now we've learned kind of like to hold a single value within an object, but there's of course many different ways, or like even like more complex ways to say things. One or more complex things in quotation marks is a vector, and a vector is just simply a list of values, right? And in fact, you can remember that everything that exists in R, so everything that is callable in R, that you are able to run and holds a value, is an object, right? That's a good thing to remember. Everything that exists is an R object. And let's take a look at those vectors. And the way we can create a vector is with the function called C. And now there's like a lot of like cells that are like Google Colab kind of like collapses them if you don't use them. You just have to click on the thing to uncollapse them if it happens to you. So if we want to create a vector of the numbers 1, 2, 3, and 4, we just use C. We have the brackets, and it creates a vector of 1, 2, 3, and 4. Now we have already assigned a lot of lifespans, and we can combine those into a vector if we execute this code. And then we have all of the numbers that we put in earlier as one vector. We can also use strings rather than just numbers, or like these are already assigned objects. These are not assigned objects yet. But we can just use strings, and strings are just text within quotation marks, right? So maybe a simple string would be hello. That's a fairly simple string, right? So it's just evaluating as hello. But if we want to have a vector of strings, then we can use quotation marks and commas in between the values, and then give us a vector that has all of those names in here. Now, of course, we can assign those vectors also to new objects, right? So they can always be, you can always go further, sort of like and create an object into a new object, and so on. So if we want to have all the lifespan in one vector, one object that we can call animal lifespans, then we execute this code. And now we should have saved this vector in our object, and if we execute it, it should show up indeed as such. All right. Now, if we wanted to get the different year conversion ratios for different animals, all the animals that we are in a vector, we can also perform mathematics with those vectors as well. So we remember the human lifespan was 122.5, but we can also actually just use the object that we created, which is maybe better. And someone asked whether you have to have empty spaces in between. You do not have to have that. And I'll just do it this way. But we can now also calculate with vectors, right? And notice one thing. If you have a mathematical operation with a vector, it also makes it back into a vector, right? So this is 122.5 divided by 392, and so on, right? So each element will be applied with the mathematical operator that you use. So now we can assign whatever we did earlier. And let me also just put this in here. So we're going to use only objects now. I will explain the difference between vector objects and strings in a bit. And then it'll come up. It actually come up in a second. So, all right. So we can also use logical operators with vectors, and they behave in the same way as mathematical operators. So if we want to find out which animals have ratios below 1, that means their maximum lifespan is below that of the humans. We could say we can get a vector of logical operators or logical answers. So the first one is true because the Greenland shark actually is older than humans. The second one is false, and the third one I think is a Galapagos tortoise. That way, yeah, you can have vector of true and false tests. All right, so small note on variable types or object types, or I guess, yeah, there's a lot of object types, but let's call them variable now. There's logical ones, and if you use the function class, then you can deduce that it is a logical vector or object in this case. We can have a string, which is just a text, plain text. That is a character or string, both is interchangeable. And if we have a numeric number, or yeah, a number, then it's just a numeric, right? There's also factors, and we're not going to go too much into them, but factors are just basically ordered text, right? So I'm a factor, so in order to create a factor, we have to actually say as dot factor, because otherwise we couldn't create a factor from scratch. But trust me, this is a factor, and we don't gonna use this too much in this workshop. But the main difference is this is plain text, this is logical and binary, true or false, and numbers you can use mathematical operators with. These are the main differences between them. Another important value, though, to mention is an A. And an A stands for not available, and that means there's a missing value. So oftentimes in data, you'll find, oh, sometimes we don't have the height of an animal, right? And the kind of a place-in for that would be an A. And an A is a value, let me put this somewhere else. An A is a value like anything else. So we can just execute an A, and it has an A. We can also use create vectors with an A. And it'll just work as a place-in for any other value it could be standing there. All right. So let's talk about logical operators for vectors. So there is a convenient logical operator for vectors that is often not taught, I find, when you teach R, and that's why I kind of make it a point to teach it, which is called the percentage in percentage. Looks kind of weird, but it's really useful. And it checks whether a list of things or a vector of things occurs within your vector, right? So it's really useful if multiple things should occur at once. All right, so let's create an animals vectors that has all of the names in them. And let's say we want to test whether giraffe, Greenland shark, or lion occurs in animals, right? So one way to do this, and we already know it, is to say equals equals giraffe, animals equals equals Greenland shark, or equals lion, and always have the or in between, right? So either this is true, or this is true, or this is true, right? And this gives us back a vector which gives us the positions of any of those animals, right? If you want to use the percentage and percentage vector, it's a bit more easier because we can simply pass a vector, right? We don't have to do this mumbo jumbo here with a long kind of list. And then we can just say animals, percentage and percentage, or you just read in animals to check. So this is the vector we just created, and it does the same thing, right? So this doesn't look extremely more easier, but I actually have an example in my slides. If I can find, I have it in a second. This is the 66. Oh. So imagine you have a lot of animals, right? So what you have to do with the or thing, and I have actually seen this, and I think I have done this myself before I knew the percentage and percentage operator. If I want to check whether any of these animals occur in my vector, I would have to do this if I don't know the operator, right? And this is really messy, right? And you have to type a lot of things. Instead, if you have this percentage and percentage operator, you can just create a vector out of all of these. And oftentimes you don't even have to create this vector because you can read in information from somewhere else and have it as a vector, and then just say animals in animals to check, and that does the exact same thing, right? So much better than writing out all of this stuff. This stuff is much easier than that. All right, I can't answer that many questions about Python, to be honest, because I'm not well versed in Python. There was a question in chat about that. All right. So we can also index our vectors, and indexing is done with square brackets. So square brackets, the way you do it is you have a vector, then you use your square brackets, and then you specify the elements that you want to keep from your vector. So if you want to only keep the first element of a vector, we would just have the square brackets here, and within it a 1, for example, right? So we would keep the first animal lifespan from our animal lifespan vector. Or we want to keep the first animal. We can also extract the 5th element, right? So this is fairly straightforward. Or we can also extract a bunch of them using a vector, right? So we can say, give me the first one, give me the third one, and give me the 5th one, the 5th one, right? And that gives us the first, third, and fifth elements of the animals vector. And if you, by the way, it's like always good to like check whether it actually does what you wanted to do. You can also just execute the animals vector and see, okay, the first element is green shark, the third element is the Galapagos tortoise, and the fifth element is the fly, right? It's always good to see like, okay, does actually what I do correspond to what I thought would be doing. All right. We can also index with logical tests. So logical tests work in a similar way, where we also have the vector, and whatever is like within the square brackets should evaluate true. That means we'll keep it. And if it's false, then that means we won't keep it, right? And the important thing is that the vectors in this case should be the same length, right? So it doesn't, otherwise R wouldn't even know which element it should keep or not, right? Yeah. So let's say we want to find out which animals have greater lifespans than humans, right? We can also, of course, always look at it, but we want to do it in a coding way, right? So we do this mathematical or this logical operation here and say human lifespan should, or animal lifespan, which animal lifespan is greater than human lifespan? That's what's written here, right? And the first element gives us a true, the third one gives us a true. Those are again the tortoise and the Greenland shark, right? So if you want to know which animals they are, and now we're mixing different vectors, right? So we have the animals vectors, and we want to retrieve everything that has a greater lifespan than humans. So that would be the first and the third element. And if we just include this logical operator here, actually give us back the Greenland shark and the tortoise, right? Because the true and false corresponds to that, right? So you can imagine we would write out this as well. Actually, I could copy paste this from here. Again, being lazy. Oh, okay. Well, this is not. Have commas in between, of course. And you see a good thing is it also has syntax highlighting here, so it actually lights up if it's a valid kind of true or false statement, right? So this would give us the same result, right? We don't want to write this out though. So with the testing, we can actually index our our vectors. Oops, didn't mean to do that. All right. Okay, so we'll take a zip of T. I'll keep what's written here, of course. Let's just write that again. Okay. Questions so far? Maybe that's a good point to ask, because functions is a bit a different topic. Okay, well, it doesn't seem to be, unless there's something in YouTube which I'm not monitoring. Okay.
We had one hand, sorry. But
oh, yeah, I didn't see that, sorry.
Yeah. Atabaki?
Yes, hi.
Hi.
How are you? Sorry, I didn't understand fully this last exercise, that what happened if we put a vector in other vector, and how we can get output. For example, what happened if a vector in vector and we want to compare it to another vector? It is one string or it is other, if I can communicate it correctly. For example, one vector have 5 variants.
Yeah.
When we put this vector to the other vector, how many variants are the other vector have? 1 or 5?
Well, it checks, it's an or kind of, right? So does any of these occur within it, right? So for example, if we would want to say, does either Greenland shark or giraffe occur in our animals vector, right? So that would be testing whether any of these two occur in our animals vector, which is I think 8 or something, right? And
Okay.
yeah, so sorry, it's the other way around. Does it? It's actually the other way around here. So this is checking whether any of the animals that we have is occurring in Greenland shark and giraffe, right? So Greenland shark is occurring in the animals, so that's why it's true. Giraffe is not in our animals vectors. We could do it the other way around, and say, does any of these two occur within our animals vector? And then we get back a list that is as long as the animals, right? It's always the left one, right? That is the deciding one of what the output is. Does that help answer the question?
Yes, but in your next exercise, you put a vector to the other vector.
Yes.
Yes. And how many variants the other vector have? It's based on this variant type, or it's based on, for example, we put A vector, B vector, C vector to the one vector. Can we do that? And how many variants are the main vector have?
I'm not sure you're referring to variant here exactly. Like, I mean, you can, like, there's different ways to index, right? So like this is an indexing by, if you have the same length, right? That's how you would do it with the square brackets. You have to have the same length, right? And it's not, it's different from the percentage and percentage operator, which just basically asks, does any of these occur in there, right? Like you could do similar things with it, right? It's not completely disjointed, I would say, but like there's different ways to do it. We could also have, I assume we could also have percentage and percentage in here, and say, yeah, so we could actually combine these if I think about it, right? So we could say, sorry, let's just have animals on the left here, right? Because the vector should be the same length as animals, and say, does either Greenland shark or Galapagos tortoise occur within it? And it should just give us the same result.
Yes.
It wouldn't take that long. Okay, right? So we can combine them, but you're kind of doing different things here, and you shouldn't necessarily mix them. But if you have to, you can, of course, right? Does that maybe help?
Yes, yes. This is very good example for me, and I understand. Thank you.
Well, I'll actually keep it, because then you can. Well, yeah, I can let me paste it in chat so you can actually have it there. Great.
Thank you.
All right. Good. Great. Let me just repair this. Great. No, it's good to ask a question, and then it's good to be clarified by this. I mean, but in general, it's good to keep in mind that you can do the same thing in different ways in R, right? So there doesn't need to be a specific kind of way to do it. But I'm giving you the tools, kind of like, okay, maybe I'm using this approach or using that approach. There's multiple ways to do the right thing, always, in a programming language. All right, let's get to functions. And same as I said earlier, that everything that exists in R is an object, we can also say that everything that occurs or happens is a function. You can think as functions as little machines, right? So there's an input to the machine, and then there's something happens in the machine. We don't necessarily have to know what it is, and then there's an output to it. And typically the inputs to these little machines are called arguments. These are the predetermined input types. So think of it, for example, a lever that you put to true or false, or on and off, or a numpad that takes kind of numeric values. And then there's the values themselves. So those are actually the numbers that you type into the numpad, right? Or for a lever, it would be either true or false, right? Or on or off, right? So you can think of this as a little machine and actually visualize this. Let me just pull this up real quick, because I have it in the I have it as well in, oh yeah, here's a GIF. Sorry, we're not going to create our own functions yet. We're actually gonna, let's Sorry about that. Gonna go to functions. Okay, so I have a little drawing that we can go through. All right, so as I said, we can think of it as little machines. And the basic setup of a function is you have the function name, and we already saw some functions, C, for example, right, or class. But let's talk about it in more detail. So you have the function name, you have the argument, and the argument is followed by equals, and then you have the value for an argument, right? This is the input, the lever. Should the lever be true or false? Should it be the number? And the numpad, should it be 5 or 6? All right, so let's look at an example, a fun example, which is called the star producer. And this is the star producer. We don't really know what happens within the machine, but we only know it has some inputs and produces stars. So the function name in this case would just be star producer, and it takes 2 arguments. So the first argument is how many? That's a numpad, right? So this is just a numeric that you have to give it. And then there's a type, and this type is, in this case, a string or a character, which is set to squiggly, right? So it might have other options. We don't know that at this point. But if we set it to how many equals 13, we want 13 stars, and the type is squiggly. So we pull the lever, squiggly shows up, then 13 stars, and I hope I counted them correctly. Then we get 13 stars, right? So that's the basic gist of it. You have a little, you have an input, specify what the input should be, and you receive some kind of output to it, right? And within the function or the machine, there's a ton of stuff that can happen, but we don't necessarily have to know what exactly it is. You can think of functions also as kind of a shorthand for code, right? So there is code within that function, but other people have prepared this for you. Or later on, we'll also learn how to write our own functions. All right. So, oh, wait, I think there's a question in chat. Does table function something similar like in %? Why only giving logical outputs? Can it give percentage? No, percentage and percentage can only give logical outputs. It's a logical operator. So it can't give percentage or something like that. It only tests for true or false. All right. So yeah, it was in the slides. Going back to the star producer. So the same graphic is in here. I just wanted to have the full screen for this. So it's important to note that like any machine, you know, there's certain kinds of arguments that expect a certain kind of input or a certain kind of value, right? So you can't pull at the numpad, right? It doesn't give you any results. And you can also can't type numbers into a lever, right? Some functions require a very specific kind of input, right? And to be able to tell what kind of input a function requires, we can use the question mark operator in R, right? So the way you can get help is to have a question mark and then a function name. And typically in R, and every function that you use in R, except you've written it yourself, should be documented, right? So, so that's really useful. That's something that is extremely useful that you have a help file directly in R. So let's say we're going to use an example function here called sec, which is stands for sequence. And we want to know what this function does, right? So we execute this code, and it should pull up, even in Google Colab, a help file, which is not as nicely formatted as it would be in R, unfortunately, but now it's running for some time. But it should pull up if it doesn't pull up, it's fine. Oh, when technical errors. Well, it doesn't put up. Anyways, oh, no, I won't. Okay. So the documentation tells us the sequence description, and it says generate regular sequences, right? So that's what it does. It creates a sequence of numbers, but it can also do other things, but we are interested in the sequence of numbers. Oftentimes, if you scroll down, you'll find the arguments. So this is a list of all the arguments that it takes. This one is just like a generic thing where the ... stands for anything. We're not going to look at this right now, but the first actual arguments that this function takes is from and to. So from tells us where should the vector or the sequence start, to where should it end, and the next one is by, which is a number and the increment of the sequence. Help function is the same as a question mark function, exactly, yeah. So we could also just do this. Well, I'm not going to run it because it's going to be weird again, but it's the same thing. Help function, yeah. So, all right, and then there's a lot of more details, and also what's always good in those description is all the way at the end, there's often examples. So you can actually run those examples and see like how is this function intended to be used, right? So in every R function has that. That is, yeah, unless the creator of the function forgot it, but that doesn't really happen. So that's really useful to have documentation right at your fingertips at all times. All right, so we learned about sequence and how what kind of argument it takes, and now we're going to apply it. And how can I close it like this? All right, so let's think about it this way in the machine again. That's why I like the slides, because it's hard to get it right, so everything's on it. But this machine is called sec, which is for the sequence, of course. The function name is sequence, and it has numpad or numeric inputs, right? So for example, gonna create a sequence from 1 to 10 by 1, right? We're gonna type this in, and the output is gonna be a vector from 1 to 10, right? Very simple. So let's try this out. The code is down here, and that's exactly what happens, right? You can also create a sequence. You can also create other kinds of vectors. So it doesn't have to be numeric. We're not going to go into that too much, but we could, for example, also create a sequence from of dates, right? So we want to have a sequence from the 1st of October 2020 to the 1st of November of 2020, right? You can actually create a sequence of these dates, which is really useful. But here we're going to just use this kind of, so you can imagine sometimes these arguments are not extremely restrictive, right? And it can actually, if a good function can do a lot of things, right? But sometimes they are. Sometimes they really expect you to either give a string or a logical vector, or sometimes it is a vector, or sometimes it's a single object, right? It can really depend on the function. And documentation will tell you about that. All right, so we've seen how to pass values to arguments in R. And there's actually two ways to pass values to functions, right? You can use the argument names. We already did this, right? So from equals 1, 2 equals 10, right? So we already did this. We already passed directly the values to the argument names. But we can also pass them by position. What does that mean, right? So by position means when to pass the values in the same order as they appear in the documentation, or as the function kind of gives you, or like as the function is hard-coded, the exact same way it is that the arguments appear, you also give it the values, right? So that would mean, oh yeah, sorry, I want to give, this is the problem if it doesn't show the things. The first thing I want to show, if you pass by names, the order doesn't matter, right? Because it knows which arguments you're giving it. So we could say 210 by 1 from 1, right? Even though the default would be like from, to, and by, we can just pass the values as we want, right? And that's a good thing to remember, that you can just add on, can you give an example of sequence of dates? That will require me a bit more. I might do it later if we have a bit more time, but I would have to actually, yeah, I would have to think about, like, I don't know, maybe on top of my head how to do it. That's a thing I would Google, for example. There's a good way to just copy paste it. Actually, let me see if that's maybe in the help file though, because that'd be cool if it just be in the help file and then we can just solve it that way. It's not, it's just numbers. Okay, well, yeah, we can do that maybe later. But good question. All right. So when I change the by to by equals 3, the sequence function gives me a logical output. A logical output, yeah. shouldn't do that, right? It's 14710. You can also do it by 2, right? Not sure then what's going on, but that should be working. Oh, sorry. 1 from equals 1, 2 equals 10 by. All right. So we can also, so as I said, we can pass by the argument names, but we can also pass by position. And by position, we know that the first 3 arguments are from, to, and by. So we can just simply say 1, 2, 10, and 1, and this should give us the same results. And this works because the positions of the arguments are the same as the values here. And oftentimes, yeah, coders are just lazy, right? They don't want to type out every single argument every time. And there's also good reasons for readability sometimes. Like in this case, it works really well. Sequence to, by, from, right? You can kind of, sequence from, to, and by. You can kind of read this really well. But sometimes not, right? And for readability, oftentimes you just want to have the function and the input, and that works just as well. So it's good to get used to it, that if you don't see the arguments, that only means we're matching by position. And in fact, I would say the majority of functions are created with the idea in mind that the first argument is kind of intuitive, right? So you don't need to look up all of the arguments. The first argument is always the most intuitive thing that you can think of. One example for a more intuitive function would be mean, or even a median, right? So we know a mean and median from statistics, from basic statistics, right? So let's say we want to create the mean, or calculate the mean of animal lifespans. We can just run mean lifespans, right? And we don't have to know what the first argument is, right? In this case, it just makes sense that we calculate the mean of a numeric vector, right? We could look it up, but in this case, and for many cases, how to open the help window, you have to actually type in you have to run this code, right? You have to run question mark sequence, and then it opens up this help window. For some reason, it took a while for the first time when I ran it, but it should open up. Another thing, like if you another good way to find this is just Google sequence R and help, and then you will also find a documentation page often, because they are also all hosted online. Yeah. I think this error sequence from sequence, I think you shouldn't have the from sequence in your code in chat. You should just only have the sequence. I'm not sure what the from sequence does. All right, so let me close this again because it's getting cluttered. All right, so we calculate the mean of the animal lifespans, and we do this, and we get an average lifespan of 94, which is quite high for the animals that we have. But of course, we also have a lot of outliers, right? We have one animal that gets 349 years old, right? So we oftentimes in statistics we use the median, right, which is the middle value that separates a string, numeric vector, so that it separates so that the half of all values are above it and half of all values are below it. That's what a median does, right? Sorry, I confused you for a second. And here we should get somewhat smaller number, right? Because then the outliers are not as present as much. All right. Now we'll create our own functions. It's going to be some exciting time. Yeah, I think we're not. Yeah, so we do need to kind of push along, because this is a bit more. Let's say this is a bit more advanced. It's still basic, but it's a bit more advanced. We're creating our own functions, but it's also really fun to create our own functions, because it can be really helpful for us to, if you want to do something that's custom, right? If you want to combine any kinds of code. So we're actually going to look into the machine now. And the way we're going to create functions is with the function, right? The function is just called function. And we do that by writing everything that should happen within this function into curly brackets, right? So The basic template or anatomy of a function looks like this. Let's ignore the name for a second. So we just say function. Then within the function, all of the arguments you want to have, right? So you can also just name them however you want. Just rename the objects before, right? So you can name an argument. You can have multiple ones as well. In this case, it's just called argument. And then we have the function body. And within the function body, something happens, right? And in this case, in this very basic example, all it would do is take the argument, assign it to value, and return the value, right? So this is very simple. And we already seen all of this stuff as well, right? The only thing that's new is return, and just tells the function which value to return, right? And what we typically do if we write functions, we also write it in this way. So we do an enter after this, and we indent it. We don't have to. Like, it's not like in Python, it doesn't care about indentation. But yeah, so we indent it so it's a bit more readable. And this function should give us back simply the value that we already put in. And then, of course, we can just name the function as well, right? We can name it what we want. Again, this function is an object then as well, but this function happens as well, right? So it's both kind of, right? Which is interesting. So let's just try out this exact function actually, and just prove to you that I didn't lie, that this will just return the same thing. Right, so I just copy pasted this. Let's give it a name. Give it back. I don't know, something like that. In real world, do you ever write your own function as an average political data? Yeah, absolutely. Like, you just absolutely always write function. Like, I always do that because, like, it also simplifies things, right? Like, I want to do a lot of things at once, right? And then use functions within it, right? So you can create even more like greater things, yeah, just a pipeline of things like cleaning data or something like that. So it's really useful to learn functions, but you can get by often without writing them, but your life gets much easier if you do. All right. So the give it back function should just give back everything we give it to it. So if I put in 1, gives back a 1 down there. If you put in hello, right? It just does the argument will be assigned to value, returns the value. Very simple. All right, let's create a function that squares a value, right? So we can create a function called square. The input or the argument will be number to be squared. So we can name it as we want, right? This number to be squared will be exponentially with 2. We will assign it to a squared number. We return a squared number, right? Again, should be fairly simple. And if we use this now, create a function, we can square. So we square 2, square 4, and so on. What we can also do is define a default value. And you notice this, that many functions have already default values, right? So we can say by default, just square the number 2. And if I leave this empty, well, we haven't seen this yet, and square, then it squares the 4, right? Because it actually has a default value that just always applies. And this can be useful if you have a lot of arguments, right? Then you want to have some already assigned things because you don't want to like specify every single thing, right? So in most cases, all functions, or in many cases, I'd say that, the functions will have sensible presets already, right? But yeah, in this case, you can just decide whether it makes sense to have a default value or not. All right, let's just keep it the way it was though. All right, so in RStudio, there's actually a really nice feature, which is called a snippet. And if you type in fun, big fun, then it'll create this template for you. Unfortunately, this doesn't work in Google Colab, but I'll just quickly show it to you just because it's great. So this is RStudio. We're going to talk about it later maybe. But it actually show up like this, right? So you type in fun, and it creates a template for you, right? So this is really convenient. Unfortunately, that doesn't work in Google Colab. I want to show it to you because it really simplifies also writing your own functions. All right, so let's create a dog to human years function. Before that, we calculated the dog to human years by just assigning it to objects and so on. Now we want to create dynamic functions that create or like make this calculation for us, right? So to answer also a little bit the question, like, do you create your own functions? Do you even need that, right? Let's say we have a lot of animals that we want to calculate the ratio for, right? Or the animal to human years calculation that we want to do. Then it makes sense to create a function, right? So there's actually like a little help or like a saying, I guess, where he says if you write the code 3 times, the same code just with different input, for example, then you should write a function, right? If you write it 3 times, it makes sense to create something that simplifies the process. So that's kind of like maybe the ballpark that you want to think about. So if you just keep writing the same thing and you just change a little thing, maybe it makes sense to create it as a function. All right. All right. Okay. So dog to human years. This function here. What we first do. So let's start with the name. Dog to human years. We could name it what we want. That's just a convenient name. It takes an argument called animal years. So that is what we're going to input. We're going to input how old the animal is. And we want to have 2 things, because remember our formula for calculating the conversion ratio is human lifespan divided by the animal lifespan, right? So in this case, we assign the maximum lifespan of humans to human lifespan, the maximum lifespan of a dog. Then we calculate the ratio. And then we calculate the animal years. Notice the animal years is up here, right? So this is the input that comes from the outside. Multiply it by ratio, apply it to human years. And the result that we're going to want to have is human years, right? So if we execute this code, then we should get the same result as above, and we do, right? So this is a very convenient way, very easy way to do a lot of operations that we always want to do, right? So like we can also just say, for example, now, if you have your own dog, you can say, how old is my dog? And just use this function to calculate that, right? So this is not an extremely useful example, right? But there's definitely ways you can imagine that you want to like automate or simplify a process of functions. All right, question on YouTube about which function, when is appropriate? I typically don't use which. So which is another way to do to index sort of a vector, right? So instead of like equals equals, you can do at which point does a certain value is true or so. It's like another way to do it. And to be honest, on top of my mind, I don't really know how to write the which function, which is another thing. Like sometimes it's okay to like not know it on top of your mind, because programmers, it's not an important thing to know actually. Just Google a lot, right? I mean the way I would find it out is just like Google it, then copy paste it in there, right? But there's there's one way to do that, right? But I don't think we necessarily need the which function. Also, we're gonna learn later how to do it in the Tidyverse, and then there's a lot that we don't need. How could we assign the input value animal years as name of the output value when saving the output as an object? As a name of the assign the input. Yeah, I'm not sure I understand the question, Milan. Sorry. Do we have to specify the values of human lifespan and animal lifespan within the function, or is it sufficient to specify the beginning of the script? Okay, well, this is a good question. It gets a bit more complex. But I would say, like, if we were to remove this function would still work, right? Like, because we have assigned human lifespan, dog lifespan outside of it. So a function will actually know all of the variables that you've created in your environment. It'll also be able to read that, right? But variables that you create within a function will never go to the global environment, right? So this ratio variable, even though we executed this, if you do ratio, it doesn't, this object doesn't exist, right? We'll have an exercise in a second, Milan, and then we can maybe go through this because it seems a bit more complex. All right. So the difference is we have a global environment, right? And in this global environment, all of our objects that we create are saved. But then we have an environment within a function, right? And then within this function environment, only the variables are that we create are kept in there, right? And they don't go outside unless you do a return, right? We could also do, if you don't want to like always assign this inside here, we could just say, well, actually, this is part of the exercise later on, so maybe I'm not going to show this. But you can actually like give both of these values as a value within here, right? So we could say human lifespan. Like, well, let's do this real quick. The human lifespan, and yeah, just keep it like this. So we don't need to say it here. And the second argument then, yes, the second argument is human lifespan. Should give us the same result, right? But yeah, there's different ways to do it. All right. Okay. Then I think we'll get to some exercises. And you can do this in your own time. Note that we want to do a break at 12. So I'll give you from now until 11:45 to solve the exercises. Then we'll come back, talk about them, and then we're going to do the break at 12. Does that sound good? So the exercises are down here. We have to expand them again. Should be fairly simple. Maybe you'll need 15 minutes. There's a few more tough ones in there. But yeah, just maybe try them on your own. I'm going to get a bit more tea. But it should all be like everything that we talked about should be in here. Like there's nothing that we haven't talked about yet, and you should be able to solve all of these tasks. So there's 8 tasks in total, and let's say a maximum of 11:45. That'd be good. All right. Actually, stop sharing my screen. I can do that. I can't. Just Zoom. Just when you like share your screen, there's a lot of stuff that disappears or is different from when you don't share your screen. Found it. Okay, and maybe yeah, if you're done, you could also indicate that maybe in chat or so, and I can see like, okay, when do the first people yeah, when are first people ready? Okay, I'm gonna get some tea real quick, but I'll be back in a minute.
Hello.
Right, I'm back. Milan, I see, with a list as output. Okay, so I see. Well, I share my screen real quick, but the other one shouldn't be necessarily diverted. From this. So I should have the right screen now. Screen one, okay. All right, so chat. So this is the function that you created. What does this do actually? Just get this out here. I see. You could just do, let's not do this data frame yet. If you want to actually have a list, then all you need to do, and let's do it outside return. We can just return this later. So you can say a list, and the name of the list should be human years, and the value of the first element of the list should be human years, and the name of the ratio should be X. And that's the output. And if I do this, you receive a list. Does that help? So you create a list, the names of the values, and the names of the list elements. Yeah, great. Question from YouTube: how do we assign all three lifespan? It's with C, then we check each one separately with, I think that's referring to task. Is it referring to any task actually? Oh, actually, in that case, oh yeah, I see task tree. No, is it task tree? Free lifespan. Because first, okay, we'll solve this when we go through it together, I assume. Like, I think that'll be easier, because otherwise I'll kind of like have to tell you the results, right?
It's apparently the second task.
Oh, okay. Well, in that case, you don't need a vector yet. That's a tip, I would say. Yes, I think that's a good tip. You don't need a vector yet. Because task 1 doesn't ask to create a vector yet. Maybe I should have specified that though. Yeah. Yeah, as I said, when you're done, then do indicate that. So I did some Googling just to figure out how exactly to make a sequence of dates. It's very simple, but I just didn't know on top of my head. By the way, to Google the stuff, I mean, how to rightly Google things is also kind of a skill. Because sometimes, right, like what exactly do I want to do? But in this case, I just Googled create a sequence of dates. My Google already knows that I'm looking for R stuff, but you normally want to do R, or sometimes you want to do R stats, because R is a letter that is not, that Googleable, unfortunately. But yeah, and I just clicked on the first result, I think. No, it actually wasn't the first result. It was this one. And apparently, you just give it a date, right? This function turns text into an actual date object type, and then from when to when, and you can actually say in years or in text by which increment it should be. So in years, you can also say 1 day, quarter apparently is also something it takes. So yeah, I mean, the code is run here, so we don't need to run it. But that's how you create date sequences, and then this can be also really useful, of course. All right. Then there was earlier question about which, again, just Google which function, because that's how you do it, right? So this is live, kind of like, okay, how do you actually do it? And I would say, like, it's yet another different way to do things, but we don't really need to do it that way, right? So, for example, just create. Where do we create that? Maybe here. Is letters already? Okay, letters is a data set that's already in here, so we can just use that. So letters is just A, B until C. And want to know at which position is the letter G, then we would have a logical test within which, and say, yeah, at which position is the letter G, and we need to do position 7. And if we want to index it that way, we would say letters logical test, or exactly, sorry, it's not a logical test in this case, but it's which position should you keep, right? And you want to keep the 7th position, so you could do it that way, right? I would probably just do it this way, and let's see the reason not to do it this way, right? Because like it's shorter. I'm not sure. So yeah, which is maybe there is a use case for which I don't see right now, but this is of course shorter, right? So just keep everything with the letter G. But if you would want to know the position, of course, right? If you want to know where in our vector does G occur, then that's a useful function, of course, right? And there could be a use case for that as well. Okay, hopefully I was able to answer the question. Could you maybe tell me what source file equals source means? I'm not sure where you're reading that. Shouldn't be in my code. I get that as an error message. Interesting. What were you trying to do?
Yeah, I'm trying to calculate the mean, and for some reason this I think I did something horribly wrong, but I'm not sure what, and I don't know what the error message.
So potentially, so the mean would expect you that you give it a numeric vector, right? So maybe check again what you're passing it and whether that is actually a numeric vector. Maybe that helps. But I mean, we're going to go over it in a second. So yeah. And actually, I remember like in my slides, I actually have something on this, but I didn't have this in the script. But let me tell you something about errors. So everyone gets errors. Errors is a normal condition in R, right? So if you already got some errors, well, welcome to the club, right? It's definitely something that happens all the time, and you don't have to worry about it if you get one. Unfortunately, errors in R are often kind of cryptic. So they don't really tell you like what's going on. Some of them are okay, but sometimes it's like whatever that means, right? There's even jokes about like there's a one particular one is like error type of subset closure is not subsettable or something like that, and it's like, what does that mean? No one knows what that means. There's blog posts about that what that means, but so unfortunately the error itself often doesn't tell you what you have to do. Sometimes it does that, so don't be discouraged by it. But I would say, yeah, check out the error message. If it doesn't tell you anything, try to see what you put into the function. And if it's actually what you wanted to do. If it's not a function, just Google in words what you were trying to do, index a vector, index something, right? Like just Google what you were trying to do and try to say it in different ways as well. And always put an R or R stats behind it. And actually, oftentimes that helps, right? And there's also like communities, of course, if it's more complex than that. There's Stack Overflow or yeah. But Stack Overflow is not really for beginners, unfortunately. I don't really like it. Those people there are kind of mean sometimes. But Twitter is nice. Okay, I think we're at 45. I'm gonna just go over the results together. All right. So the first task is pick 3 animals from the animal license data we haven't talked about yet. Assign license values to respective objects with appropriate names. All right. So in here, and I could have been more clear. Maybe I can just want to create new animals, right? So for example, giraffe lifespan. In this case, it's 39.5. And what else is there? Penguin, I think we haven't had. It's 26. And elephant, I think we didn't have.
Fabio, you're not sharing your screen.
Oh, I'm sorry. Well, beginner's problem. Sorry about that. Well, I didn't do anything too exciting. Not yet. All right, so we'll just execute these codes. We can also just do it in one. Just chose to do it 3 different ones. Create 3 different logical tests which compare the maximum longevity between your chosen animal lifespans. All right, so let's say, is the giraffe lifespan the same as the penguin lifespan? Probably not true. Is it? Again, I'm just copy pasting stuff. It's just. Oh, and one good note for coding also is if you do double click, it just highlights the entire string or object in this case. That's pretty useful. Is giraffe span longer than penguin lifespan? Well, it is, because it's 29.5. And finally, let's do something with the elephant lifespan and say, is it not equal the penguin lifespan? That's true, of course, right? They're different. All right, so create two vectors with help C. So one is the all of the lifespans. So it's giraffe lifespan, it's penguin lifespan, and it's elephant lifespan. Let's call this my lifespan, or let's just call it lifespans. And let's create a vector with the texts. Well, I kind of did it in a different direction. So actually, number one is that lifespans and the animals. We have a giraffe, we have a penguin, and we have an elephant. Oh, I just mistyped elephant. Did I not? Yes, I did. Big mistake. No one noticed that, of course. Not a big deal, right? But let's be precise here, I suppose. All right, create the vectors, calculate the means. I'm not sure what you did wrong, but like since this should be just numbers, this should just calculate the mean. I'm not sure, and the error you just mentioned, actually, I remember having seen that before, but this should be calculating the mean. All right, retrieve the second value of the vector that contains the animal names. Square brackets are your friends. So we take the animals vector and get the second value. We use square brackets, and this is that. Find out which animals in lifespan vector have a maximum longevity of above 25. We just copy paste. In this case, we need a lifespan, of course. Oh, yeah, we need the animals. And want to subset the animals, or I call it the animals. And we want to know which ones of them have a longevity of above 25. So we have the lifespans vector and everything that's above 25, right? So this evaluates to a vector of true and falses, and it should only should give us truths for everything that's above 25, and only keep the truths with those square brackets. And in this case, all of them are above 25. It's good. So maybe sometimes you get none, right? Depending on whichever you did. Exercise 2. No, don't do that yet. Actually, don't do the exercise 2 yet. Did I miss something? In task 2, is it possible to receive the name of the animal from the name selector? Would you teach that? Yeah. Yeah, that's exactly it. That's what I taught. Yeah. All right, so that's how you get the name of the animal, right? The animal conversion ratio. Well, we take the lifespans, and we have to do a human lifespan because we already have that assigned. Divided by the lifespans. Here are all the conversion ratios. It's then conversions. And yeah, let's calculate the human years for the picked animals. So we have all these, again, I mistyped, conversions, and let's find out the ages when they're 5 years old, right? So here are all of the, how old they would be. So let's see, what are the animals again? I'm going to show you set names, because why not? Set names is a function that you can have also have named vectors. That is something that is useful sometimes, but not always. All it does is assign a name to a vector or to elements of a vector. And you can do that with the function set names. It takes the vector as first argument, and the second is the name of the a vector of the names. And we have that, of course. That is the animals. That's how I called it. And it puts in front like this little thing, and they behave exactly the same as numeric vectors as well, but it also have the name attached, so it's kind of useful. All right. Seems like the elephant is the oldest. Well, age is the oldest. Sorry, the least, of course. This is the higher up is, yeah. All right, so task 8 is pick one of the animals you chose and create a function which takes input animal years and outputs human years. Test the function and validate the results in the 7 exercise. Okay, so maybe let's create a function that calculates a penguin lifespan in human years. So one thing to do, again, coders are lazy, is literally just copy paste what's up here. And you might have done it differently, right? But this is just the easiest way to do it. So create a function here. Let's call this penguin to human years. Let's do a default thing where we say human lifespan is 125. Maybe it changes at some point, right? So we can have a different, but default one is 122.5, so we don't have to give this. And of course, we want to change the penguin lifespan. Again, let's have this as a default value. Why not? So it's a bit different. The penguin lifespan was how long? It was 26. So king penguin, actually. So 26. So now human lifespan is down here. It highlights it for us as well. Penguin lifespan, we have to adapt that. And yeah, here's our penguin to human years function. We calculate the ratio, then we multiply it with the animal years that we give in at the human years and return the human years. And let's do the 5. And 23.5, our point, yeah, 0.6, I guess. And that is also what we find here. All right. We have 5 minutes left. The exercise 2, actually, I wanted to delete that. So there was something here before, but we're not going to get to it, obviously. So I'm just going to delete this. Sorry about that. Okay, we have 5 minutes more left. I actually wanted to go into data frames. I'm going to talk a little bit about it. And then at 12, we're going to go into the break. But I'm going to talk a little bit about the data frames, and then we're going to pick up after the break where we started. Okay, so data frames. So far we only like kind of munched a little bit with vectors and so on. But the main thing when you use R for data science is data frames, right? And data frames is something that actually you already seen before. A data frame can look like this, right? So it just has a column and a row. And the column has a name, for example, animal in this case. And here are the animals listed, and then a maximum individual. This is a data frame, right? You might notice also from Excel or so on, right? So like this is a very typical way to display data. But data can also come in lists and JSON files and all of that stuff. So data can come in very different formats, right? Well, typically, data frame describes a rectangular data set which has rows and columns. All right, so let's create a data frame. I've done a lot of pre-work here where I just assigned a lot of individual variables. So this is basically just lifespans, and then have them in one vector as animal lifespans, and then have the names of the animals as well in the same order. So I'm executing this code. I'm going to run the data frame, and this function data frame just creates a data frame from 2 vectors. And in order for this to work, they have to be the same size, right? And they also, of course, have to be in the same order because it assigns each individual vector to its respective counterpoint here, right? So Greenland shark, the first value here, and also the first value for animal lifespan. So otherwise it wouldn't work, right? Or it wouldn't give us the right way. But oftentimes we don't actually have to create them ourselves, right? So this is just an exercise to work with the data we already have. All right, of course, we can also assign data frames to new objects as well, just as we would do with actors, right? So now we have an animal data object, and now within it is the animal data. Now we can look into what kind of shape our data set has. So for example, if we use the function encol, it tells us how many columns we have. So to that, 2 columns, right? It's the animal and the lifespan. If we run nrow, we can see how many rows the data set has. In this case, it's 9. We have 9 animals. In this data set it is. And we can also use dim. It's less than you oftentimes not use that much, but does the same thing. Just gives you both at once, right? So dim gives you the rows first and the columns. So 9 rows, 2 columns. All right. If you want to figure out the names of our data set, right? Like the variable names within our data set, then we can just use the function names. And it gives us animals and lifespan. So why would we want to know the names of variables? And I'll just talk quickly about this and then probably going to go into break. But sometimes we want to subset or just look at certain variables within our data frame, right? We don't want to look at all of them. Do you use data table as an alternative? I personally don't. Someone asked, do you use data table as an alternative to data frame? I personally don't use data table. It's an option, but data frame is just what's built into R. So that's what we talk about at first, right? Data table is another R package that does similar things, but I personally don't use it. All right, so if you want to retrieve a variable from within a data set, we can use the $sign operator. And the way we do it is data set dollar variable name, right? So let's say we want to extract the lifespans of animals, then we do this. So animals data dollar, and then whatever the name was, we know the names from this. And then we have a vector, right? So a data frame is just vectors combined. We did this together, right? The data frame is just vectors combined, and that's how you retrieve the vector again from the data set. And then the output is a vector in this case. So if we want to add the list of animals in our data set, we can do this with $animals. Unfortunately, in our Colab, you can't do autocomplete with $signs. If you're in R, it's a very good thing to just click tab whenever you are on the $sign, and then tells you whatever is in the data set. Very useful. I'll show that real quick to you, but unfortunately we can't do this in Colab. But because oftentimes you don't know what's in a data set, right? So this is an example data set in R called cars, and we see there's 2 variables and it's beat and this. You can actually click on them. Very useful, but unfortunately, not. But I want to show it to you. Oops, sorry, clicking for things. All right, I think it's 12. And that means we're gonna have a break. I think we're gonna have a break until 12:15, if that's okay with you. If anyone is opposed to it, like it's gonna be, I need more time than that to process all this, then you know, speak now. But I think 15 should be fine. All right, great. Then we see each other. I think there's going to be a video. So whenever the video ends, like let's say 12:16 or so now, 12:17, then try to be here. At the latest 12:20. All right, let's say at the latest 12:20, but try to be here a few minutes earlier. Good. So far so good. I'm going to get more tea, and yeah, see you later.
How can we reduce CO2 emissions? How can we fight the coming pandemics? And how can we strive towards a democracy that supports everyone's needs? In our dream for a better world, we face complex questions. Policymakers and governments are challenged with finding practical and sustainable answers to these issues. Data science can help us find those answers. But what is data science? And how does it actually work in the real world? Using the tools of data science, policymakers can identify problems and create targeted solutions that make a difference. Take traffic. If you look at traffic cameras, we can understand the number and types of vehicles and where congestion happens. If we use that data responsibly, we can reduce emissions and create healthier cities. However, simply understanding the problem and how to read data is not enough. We need to deliver results, come up with a solution. For our data insights to matter, we must communicate our results simply and effectively, and we must convert them into policy. To do that, we need to understand how policymaking works. How you can turn an insight into change. We need to create solutions that don't just follow algorithms blindly, but serve the common good. The Hertie School's Master of Data Science for Public Policy tackles that challenge. We work on real-world problems today. Using data science combined with public policy expertise, we can both verify theories and support their decisions with data. It is our mission to enable responsible problem solving for the most important global issues. Will you join us?
I think one of my favorite things about Berlin is this is how it's explained it to my families. You can live in a point of history and any point of history in the same city. So you can be walking through the next to the Berlin Wall, parts of the Berlin Wall, and then you can be right next to a museum about the Holocaust, or you can be talking about how the German Empire came. It's such a city. It's a city that has so many connecting histories that at any point you can be in a completely different part of history, and that I think that's one of my favorite things about the city. One of the first meetings that we had was with Michael Swern during our introduction and all of these, and he mentioned this idea that there is one big liberal script that exists out there. And I remember thinking, I don't agree. I don't think that's true. And so that's actually influenced how I've shaped my question. My questions are very different from what I proposed. And now it's shifted to almost a challenge to prove that there is more than just one liberal script. And I'm using kind of a gender perspective to be able to prove this. And so it's really, through interactions, it's really helped me shape kind of how I'm viewing the world and how I'm viewing the next steps I take on my research. I have always been interested in gender, but not just necessarily gender, but the idea of empowerment and representation. Because of my background, because of the fact that I'm from Puerto Rico and I know what it's like that my island has no representation in the United States. We have disenfranchised and we have a history of colonization. And so because of that, I have become very receptive to questions about empowerment and representation in institutions, in organizations. Regional organizations came into mind because we've always thought of international organizations as these big actors, but in reality, regional organizations have a lot more interaction with the people and go beyond the state as well. They can in some ways control or influence the state. And I chose Latin America because of the same argument that I previously gave, in that Latin America is usually shown as having no agency whatsoever, and I want to show that regional organizations within Latin America have their own agency, and they can influence the inclusion or the oppression of LGBTQ, women, and minorities within the region. For my master's, I did research on Latin America for my master's thesis, and it's also on gender, but it was most specifically on regional organizations in Latin America. And what I noticed through reading the literature was that a lot of the times Latin America itself and organizations in Latin America are not given enough agency. They're usually, in a lot of comparative work, they're assumed as being influenced by the European Union, shaped by the West. In other words, Latin America itself just receives, doesn't give into these conversations. And I think that could lead to the assumption that there is one liberal script if we only see it from the Western perspective. I believe that if you open Latin America and say, what do scholars and philosophers in Latin America say, what do leaders there say, it might actually prove that there are different aspects of the liberal script that we haven't even thought of in our conceptualization on what a liberal script is at the moment. To me, the most important aspect is the ability to interact with so many people of so many different backgrounds and have very different approaches to research. Right now in my office, I am sitting with two doctoral students who do quantitative work, which is beyond me. But it's also, they also, when I discuss my research, they're willing to look at it from a different perspective as well and say, hey, Andrea, maybe this doesn't make sense. Think of it this way. And then I, in some ways, can also help and discuss their own research and say, hey, maybe the numbers don't tell the entire story. And so I think that is the most exciting aspect of this, of the entire cluster. And also just how we are viewing, we all think there's this idea of the liberal script, but if you speak to each and every single one of them, they'll have different ideas of what the liberal script is. And so I think that's also one of the most exciting aspects of it.
All right, the video ended. I'm gonna wait a little bit. Oh, I said 16, 17. Let's wait for 18. 10, everyone should be back. Yeah. I got a fresh cup of tea and ready to go into our afternoon. Or, yeah. Okay, 12:18. So I'll slowly start sharing my screen again. Okay. It's hard to know, right? If people are back. Like if you're in a physical room, you're like, oh, people are here. Can I get a hear if people are here in chat? Okay. People exist. That's great. All right. So a lot of people are here. It's good to see. All right. Well, in person there would have been a bit, more of an experience. So, but I hope this also has its upsides, to be honest, right? Like having a screen before you, right, and you can work with your screen better. And you can work in pajamas, of course, right? I'm not wearing pajamas now, of course, but you could wear them, right? All right, let's go into it. Before we had our break, oh, I clicked on something. Oh goodness, I have a thing here. Okay, how do I make this away? Now I'm a really boomer. Okay, all right. Can I remove this? I don't use Zoom that much for presentation. Okay, I can remove it. I'm so sorry. All right, I clicked on something and disappeared. Okay, retrieve variables. That's the last thing we talked about, and we use the $sign to retrieve them. That was the last thing we executed. So we got the animal lifespans data vector from within the data frame. Now we can also recode variables using this logic, using the $sign logic. And in order to do this, we can just assign to a $sign and then a variable name. It doesn't even have to exist yet, right? So if we say animals data $sign animals to human, this doesn't, like this variable doesn't exist in our data set, right? Remember, we only had 2 variables in our data set, which were animals and animal lifespans. So this doesn't exist in our data, but we're simply assigning to it some kind of vector that also has to have the same length. And in this case, we say animals data $sign animal lifespans divided by human lifespan, right? So we get the conversion ratio, and we attach it to the data set this way, right? So just to be clear before we do this, so this creates a vector that is of the same length as the data set has rows. And so that's why it works, right? And we can assign it, then throws no errors. And now we actually do have a variable that's called that. We can also overwrite a variable, right? We can also say animal lifespans. Well, if I overwrite it, I have to execute it again, but whatever. And I lied a little bit because you can have the same vector size, but you can also have one single digit or single value that you can give it, right? So you could say all the same. Not sure why you would do that, but now we have a character vector which is all the same, right? So you can either give one or the same length as the data set for this to work. Let's remove this. And I want this to have animal to animal to human. And actually, let's rerun this up here because I don't want to overwrite it. Okay. All right, so here's a new column that we just added to it. And it always adds it at the end of the data set as well. All right, so let's get to indexing of data frames. So same as with vectors, we can also index data frames. And the way we do this is we specify the data set. And since it's a two-dimensional thing that we're looking at, right, we have rows and columns. We don't have just a one-dimensional vector with just a list of values, basically. We also need to index by two values. So the first value within, oops, I didn't want to do that. The first value within a square bracket would be assigned to rows, and the second one would be assigned to columns. So let's say we only want to keep the first row and the first column. So that would be the upper left cell, right? That would be this cell here, right? It's the first row, first column, green and chart. So we just do this. By the way, this is a useful R error. If you just specify one, I think it says, oh, this works. Wait, normally it's frozen error. I'm pretty sure it's normally frozen error. It says like not the right dimensions. Maybe there's something Google Colabs. Google Colab does it differently. I normally think it should throw an error. Okay, well I lied. consider me proven a lie. No. Anyways, you normally have to specify. Oh, okay. Maybe this is new in the new R version. Okay, whatever. Let's not get confused with that. But you have to say 1 and 1. You get the first cell, right? But what you can do, and maybe this is new, and I have just not freshed up on this yet. But if you leave one of those empty, it will give you everything from that row or column, right? So if you leave the column section empty and only say 1, it should give you the first row, right? And this is the first row of the data set. If you leave the rows empty, but say 1 for column, then you get the first column. And in this case, you get the vector of it. And so I'm not sure like why it would work that it would give you the first column. Like I've actually not seen this before and I'm confused by it, but okay, let's just assume that's what happens now. But normally you would do this, right? You would say comma and then leave it empty. That's at least how it was some time ago. And I look into this actually if I have a break or so later, because I'm curious now what causes this. All right, so rows, columns. And we can also use logical tests within data frames. So we do something that we've done before. We want to find out which animal lifespans are longer than human lifespans. So again, we just use the $sign to reach this vector within a data frame. And we can do it the same way as we did with the vectors, right? So if it evaluates to true, it keeps it. It evaluates to false, it removes it, right? So so we have this true and false vectors for the rows. And if we give this true false vector to the rows, it will only keep the rows that are true. In this case, it's the rows that have animal lifespans that are longer than humans, right? So we execute this, gives us exactly that, right? So this is longer than human, and this is of course also longer than human, or at least a value that we provided with. All right, so so much about data frames. We're gonna use data frames again, and like this way of manipulating data frames is what we generally would call base R. And base R is whatever is already within R. And in a lot of cases, a lot of cases, it's totally fine to just use base R. It gets you pretty far, but there's also kind of a new kind of universe around there of a lot of new code that isn't directly delivered out with R. And here we talk about R packages. R packages, and actually let me go into my slides here because I'm going to talk about a little bit about R packages. R packages are basically, let me go into full screen as well. They're a collection of functions that you can load into your working environment, right? So this is functions that other people have wrote, and they contain those code, and oftentimes it's kind of curated by the community, and the community again is very active. And it's really good to know what kind of packages are out there because they can make your life really so much easier, right? So there's some stuff in R that's kind of wonky if you just use it by itself, but also like statistical methods and doing natural language processing and all that kind of stuff. There's specific packages for that, right? I talked a little bit about some. The Tidyverse is a collection of packages, for example. I talked about easy stats. So there's a lot of like functionalities that you add to it, and some of these are really, really well maintained, right? So you don't have to like worry a lot about like, oh, you know, who creates these and like what is their motive or so. Some of these are really well maintained, and of course they live from the community. And yeah, but it's a great addition, and there's a whole new world besides the space R idea. And when we do data manipulation, we will learn soon the Tidyverse, which allows you to do this kind of thing we did, just indexing and so on, in my opinion, and this is an opinion, of course, in a smoother way, and that's why we learned it. All right, so I just keeping track of packages sometimes, and if you are on Twitter, follow the hashtag #RStats. There's a really cool website called Posts You Might Have Missed if you're not on Twitter, and they just post like it's a collection of like tweets, basically, of like very cool stuff that people are working on. And I am always like flabbergasted by like, oh, you know, you can do this, you can do that. Like it makes life so much easier. So it's really cool to like reinvent and rediscover like cool things that you can do in R that you didn't know maybe before. All right, so installing packages in R, you do that with the function called install.packages. This is one of the cases where there's like dots and functions and so on. Like base R doesn't always conform to that, but anyways. Janitor is a really nice package we are looking in the near future. And if you install a package, it's on your computer, right? Installing means you can think of it as kind of like buying a new set of tools. In this case, all packages are free. So you get this on your computer, you buy it, but it doesn't mean you can work with it directly. You have to actually put them on the table or like put it in your working environment. And you do that via a function called library, right? All right, yeah, we'll go into the Google Colab in a second. But I'm just going to use the slides, but this is actually also in the Google Colab. You can actually definitely go to it as well already. But yeah, there's going to be a little bit of talking about stuff. So let's talk about the Tidyverse. The Tidyverse is a collection of opinionated collection of R packages, which is specifically designed for data science. They all kind of share the same design, the philosophy, and data structures, right? In my opinion, this is really, really what drives R forward. It makes it much easier, and for me, it's always important that it's easy. There's no need in making things overly complex. It should just function, right? It just should be something that is fun to you and is easy to work with. And for me, of course, you know, you get it from me in his opinion, but I think there's nothing better out there to work with data. Take it as an opinion from me, right? And not as a state of fact, let's say that. But it really, really enhanced my understanding of data. And why? Because it has this logic designed where you go from everything from importing the data into your working environment to tidying it up. So tidying means bringing it into the shape that you can actually work with it. Then transform means, oh, you know, you want to calculate new variables or, you know, separate a variable and like all kinds of stuff to do with your data so that you can actually like visualize it, for example. Then there's also a framework about modeling it, so creating statistical models. And within this is also, which I find really important, a part of communicating this, right? So there's a lot of stuff that you can create, for example, slides with, or interactive web apps, or dashboards and so on. So it goes all the way from messy, whatever that is, we can't really get any insights from it, to really nice visualization, statistical models, and interactive dashboards, right? So it's an entire data science pipeline. And we here will only, we can't ever focus on all of this, but we will focus on really the transform part, a little bit on the tidy part, or the tidying up part of it, and the importation, because of course we need to import the data. But really we are here in this kind of pipeline within this workshop. All right, so a core principle of the Tidyverse is tidy data. So what is this idea of tidy data? It means every column should be a variable, every row should be an observation, and every cell is a single value. So what does it mean every column is a variable? Well, every column in your data set should be referring to a variable, right? So for example, an animal is something that varies, and only that, right? And a maximum lifespan and so on. So we already seen actually a tidy data set. This is a tidy data set because every row is an observation, right? So every row you can see actually refers to a single animal in this case, and every column refers to a specific value about that animal, right? So there isn't like multiple values in here or not. So this is actually a good example of a tidy data frame. And this, and this is the format that typically you want to work with because it allows us to do really powerful things. So there's also examples of untidy data, for example, right? So this would be an untidy data set of the same data that we already saw before. And this has not every row is not a single observation because we have actually 2 times domestic dog, and we have a variable called type, and it says lifespan and ratio, and then the value sort of specifies, okay, this is the value for the lifespan, this is this value for the ratio, right? So it's a perfectly okay data set, and in some cases you actually need data set in this format, but it's not a tidy format, right? And actually this is called a long form data set, and for some use cases this is useful, but like the basic thing you always want to get data into is 1 row per observation, and every variable is a column, and every cell is a value. A different way to have untidy data, and sometimes this happens with Excel sheets or something like that, is where within a single column there's multiple sort of values, right? So this again doesn't qualify as a tidy data frame. We have to like separate them out because in every cell we need a value and not multiple values. So when I ask, what about panel data, observations below each other for different point in time tidy? There's some debate about that, but yeah, you could say it's tidy data because like every row refers to a point in time of that observation, right? So that's fine. That could be a totally fine data set, right? So panel data would also qualify as tidy in that sense. Then, so every row should have a discernible case. Let's say it that way. Yeah, and you can also group by time and also space, of course, right? So if you have geographical units or so. Okay, so this is a really nice graph from a really nice artist that I like to follow and also quote often. The tidy data sets, they're all alike, right? They all have this like rectangular idea. Every row is an observation, every column is a variable, and they're all alike, but messy data, they're all messy in its own way, right? So kind of a play of I think Tolstoy or so, kind of quote about families. But that's the idea, that you want to bring things into this consistent shape so we can work further with it. And we could want to have a different format, we can do that, but always from the base of a tidy data set. So the 2 disadvantages are they're consistently prepared, it's easier to read, process, and load and save. And a lot of the procedures that we will use are associated and expect this kind of data set to work with. All right. So installing the Tidyverse, pretty easy. Install all the packages. Tidyverse gives you all the packages. It's a ton of them. Don't worry too much about like understanding like which function is exactly in which package. I didn't understand this until very much longer. Just assume that this is like the package you will need for all kinds of data science stuff. Let's say that. All right. Yes, then we load them. But before we want to jump more into like actually working with the Tidyverse, I want to introduce a new data set. One that is a bit more complex, has a bit more variables, so we can actually do a little bit of tidying up and cleaning, right? So we will stay within the animal kingdom. I really like animals, just fun to watch in documentaries and all of that stuff. I don't know. Either way. And we will stay within the animal kingdom, and we're actually going to use the polar penguins data set, which is a common data set which is used for introduction of data science. I really like it. I really like penguins. Penguins are cute and wobbly. And I think it's a really cool data set to use. And there's some really cool illustrations along with it as well. And this is actually, I think they were studying like the mating behaviors or like the sexual dimorphism within penguins, something like this. And it's like a data set about penguins in the Antarctica. Yeah. So I think at this point we'll actually go to the Google Colab because I'm going to read in the data. And the second data manipulation Colab should have been posted in the chat, but actually let me reshare it, I guess. It's up there, actually. See, okay. But you'll also have it up there. So these are the same links. So I talked a lot about this already. R packages, the Tidyverse, untidy data. Talked about this stuff. New data set appears, and now we're with the Palmer penguins. All right. So first of all, we have to read the data into our working environment, right? And the way we do this is we can use the function read CSV. It's actually from the package reader. Just going to mention it. Don't worry too much about it. And it goes read underscore CSV because it's in a CSV format. And actually, there's really some pretty cool and powerful stuff that you can do. Is just read from a URL, right? So this URL here directly leads to the CSV on the GitHub repository. And we can read from that URL into R. Pretty straightforward, pretty easy. We don't have to like have any physical copy of it anywhere. And it's good for a workshop to work this way. So we do this, and you'll notice that read CSV will have some outputs because it will automatically try to parse what kind of inputs could not find functional that didn't execute. So you all encounter errors, right? It's totally normal. In this case, this is kind of useful because it says it could not find function read CSV. This tells me I haven't loaded in the right packages because it doesn't exist. That function doesn't exist. And why doesn't it exist? Well, I haven't loaded in. I haven't put my tools on the table. And of course, if you want to do work, you have to have the tools. So I'm going to run this. It tells us how it loaded in all of these like Tidyverse packages. And now I should be able to execute this. All right, so there's a bunch of stuff. It'll tell you like, okay, the study name, it parses as a character. Excuse me, the sample number is a double, it's just a number or numeric, a specific type of numeric. And it parses as a character, and actually parse something as a date as well, really useful. You don't have to like worry about it. There is a base function called read CSV, and it sometimes behaves kind of weird. Like a read CSV, read.csv is the base function for it. The read underscore CSV has a lot of like internal things built in that helps you a lot with like reading in data. I would always use this, unless you really want to be specific about like how you read in the data. But I think this one is really useful for beginners for sure. All right, so we're gonna delete this, or the output at least. And now it's the data set, and we have scroll all the way up. It says we have 344 rows, first thing is rows, and 17 variables, 17 columns. And this is actually a specific kind of data frame. It's called a tibble. There's not much more to know about it. It's kind of like within R, it like printed out in a more tidy way, more neat way. But it's basically a data frame, right? It's called tibble, basically a data frame. Not much to there's a lot to know about it, but not much you need to know about it necessarily, right? So just assume it's a data frame, a special kind of data frame. And if you want to look into this data set a bit more in a tidy way and not have those like huge columns and everything like an Excel spreadsheet, we can use Glimpse, which is the Dplyr package. Again, these are within the Tidyverse. And this is really useful to just get a very quick overview of what kind of variables are in your data set and what kind of type are they. And yeah, what are some initial values of that data set? So for example, there is the study name, and these are the values of that variable, right, the individual elements of it. Then there's sample numbers, 1, 2, 3, 4, species, we have from which region they are, on which island they occur. I'm not sure about all of these, but when their egg, I guess, was hatched or created. Common length is their, how's it called? Actually, it's up here. The bill. It's called bill for penguin, I suppose. And the flipper length, the body mass, the sex, and there are some coordinates in there as well. So there's a bunch of variables in here. And a typical data set would look like this. Here's something that's sneaked in that I don't need. All right, so let's do some initial data cleaning. And for that, we will use the janitor package. Janitor package is an absolute favorite of mine. It's really, really, really useful. And I use it in 99% of my code that I write, because it has a very powerful function I will see in a second. But actually, it's not part of the Tidyverse. And it's developed by someone else. But it definitely follows also tidy principle. And one tidy principles with the functions to remember is that the functions that follow Tidyverse style always take the data as the first argument. And you'll see this a lot now from going on forward. So always the data is the first argument, and whatever you want to do with the data follows maybe as arguments or is already within the function itself. So we're going to use janitor for cleaning, or at least for for a little bit of the cleaning, and then we'll move on to other packages. But this is not installed by default in Google Colab. Tidyverse actually is, so we only had to do library Tidyverse. You actually have to install the janitor. And let's just do this. Oops. Let's just do this together. By the way, I haven't mentioned this, but like a hashtag just means the code is commented out, so it won't run. This is just useful if you want to have an annotation within the code. So we remove the hashtag so it can actually run. And then we run this, and it's important that you run this as well, because otherwise you won't have the tools in your house to put on your table. All right, so all install packages processes have some kind of like technical mumbo jumbo that no one has to understand, but it basically means installing the packages. Some of them are really long, but it means it works, usually. All right, so we have loaded it, we have installed the janitor package, we have loaded it in, and now we want to clean our data set. So one annoyance with this Penguins data set is that it has variable names where there's spaces in there, and R really doesn't like that because it has to unquote those, right? So typically we want to have variables or variable names, object names that have no space between them, right? So that doesn't square that well with R. You can use them, but you have to quote them in with these accents. I don't know like what exactly the name for it is, but these little things here so that it actually works. So we don't really want that in our data set. We want to remove them as fast as possible, right? And there is this really useful function. Oh, actually, I showed it here as well. So if you want to call a variable within this data set, you have to do this, right? Which is you can do it, right? And it works, but it's not a good way to write code, right? And then actually here's all the values from both of these data sets. And one thing to notice here as well, though, is notice that there's an A's here as well, right? So we don't have every observation for every penguin in our data set. Okay, so what janitor really helps with is cleaning the names, cleaning your variable names. Why clean them? It's really important because you have to call your variable names all the time, right? You have to like write them down. So you actually want to have good, legible data variables. You don't want to have like really long, messy stuff. So what janitor does is it runs a bunch of algorithms over basically and puts it into lowercase snake case, the one that we want to have and the one I want to go with. So it just takes the data set as its first argument. Before we assign, let's just run it without it. And if we scroll all the way up, we can see that it turned it into lowercase snake case, right? Study name, sample number, species, and so on. So one function turns all your variable names into legible, nicely formatted names, which I really like. So we assign this into a new data frame. We call it penguin clean. It's good to save your variables in between if you do something like this. And we can also look with glimpse to have a view of. Oh, I didn't execute this yet, of course. Again, learning from errors. Object penguins clean not found. Why? Because I haven't actually run this up here. I've only run it without the assignment, right? So we haven't saved this version, right? We just executed it. So we actually have to assign it, run it, and now it'll find, of course, the data set as well. And then we can see how it clean it up. And here we saw some brackets and stuff. It also removes the brackets, right? So that it actually only is letters or numbers. So really useful. We have another problem in our Penguin data set, and that is that we have some variables in there that are just basically constants. So it's all the same variable for, or the same value for a variable, and that doesn't give us a lot of information. So typically, you want to remove them. Sometimes there's reasons to have them in there, but there's a really nice function in janitor called remove constant, and this just removes all variables that are the same across all rows, right? So if a penguin has the same value for, then there isn't much more information that you want to have about it. And one such variable is region. So all of the penguins actually were collected or are found in the same region. And we use the function table. This is a base R function actually, just to count, just to see frequency counts of a variable, right? So this is a really nice way to find it. And then let's just try a different one. Now I try to do tab and see what is in there, but it doesn't work in Google Colab. But unfortunately, but we see it up here. So we can say, what is there? Sex, I guess. Right, so we can see the counts per category, right? And there's 165 females and 168 males. Useful function. All right, so we run the remove constant. Let's do this first without assigning it. As I said, the first argument is always the data. It's always going to be this way. And I also turn quiet to false, because in this case, we may want to know what it's removing, right? So maybe like it's removing something that we don't want to be removed. It's really useful. It gives you some output like removing 2 constant columns of 70 columns total and removed region. We already saw that in stage. The stage was also the same. I think said something about the eggs here, adult 1.8 stage. So in this case, we might want to remove it. In this case, we do want to remove it, but it's a useful function. It gives us a very useful output. There's another function that's also very useful. I'm not going to apply it here because we don't need it, but it's called remove empty. And that just means remove any rows or columns that are completely in A, right? Again, they might not have any information that we need, right? If they're completely in A across all your rows, right? If you imagine there's a penguin as a glimpse, like this is always refers to the first value, and like it would just be all in A, like not even an ID or something, then this doesn't include any information at all, right? And similarly, if the entire column would be in A, again, wouldn't include any information, doesn't need to be there. But we don't have that in our data set, so we can safely ignore that. All right, so far with janitor, we'll go with the Tidyr functions, which is something that is in the Tidyverse. There's a logo. Every Tidyverse package comes with a nice logo. It's also fun, the stickers that you can put on your laptop. But anyway, so Tidyr is for tidying data sets. Also, there's a couple more things, but that is its main purpose. And we can see, for example, that our data set is not entirely tidy yet, because if we look at the species variable, we can see it says the common name of the penguin, but it also has the Latin name of the penguin in brackets. And this, of course, goes against the rule that there should be a single value per cell, right? We could keep it this way. It's not a big problem, but for intensive purpose of showing how this works, we'll clean this up and actually separate this out. So there's a useful function in Tidyr called separate, and what it does, you can imagine it separates two columns, and it takes 2 arguments, takes more arguments, but 2 main arguments, which is sep, and that's by which character the value should be split, or a sequence of characters, and into, which is a vector which specifies the resulting new variable names, right? So what does this mean in practice? So let's move the assignment for now real quick and just look at how it's written. So again, data set first. Then next argument this takes is which variable, right? This is again actually a kind of a convention in Tidyverse functions. If it's a function applies to a variable, then first comes the data set and then the variable. And notice how we don't have to specify any quotation marks and so on. This is another Tidyverse thing where it internally knows how to match it, and you don't have to specify the data set again. So you can just simply write the variable down. Be careful though, because sometimes like when a function doesn't follow this Tidyverse principle, you can't do it this way. Because like if it's a base function, then you would have to do something like this. But here we want to use a tidy function, which does it automatically, and you don't have to write the data set all over again. You include the last bracket while cleaning. How can you exclude? Yeah, I'm gonna show this. I'm gonna actually show this. Yeah. So we're gonna separate by the opening bracket. So if you look again, like there's an opening bracket and a space. So we're gonna write that opening bracket. What's this? This is called what's it called again? This is a regex operator because you have to comment out sometimes special characters, and the bracket happens to be a special character. And the way you comment, like how do you actually get a bracket and not the special character bracket, you have to do this, right? So don't worry too much about it. It's called regex. It's a whole other universe. But that's how if you have special characters, you comment it out with those slashes, and 2 of them in R. In other languages, I think it's only 1. But yeah, so empty space bracket is a separator, and then into, these are a vector of variable names that you want to put it into. Actually, I do gonna assign it because we want to maybe look into this new data set real quick. And now we can see the species. And now it only has the penguin and the Latin name, right? And now the Latin name is in its own column. We tidied it up a little bit. Someone said, you included the last bracket while cleaning. How can you exclude it? There is a package that we're not going to go into because it goes a little bit into natural language processing or string manipulation, I guess, but it's really nice package to use, but we're not going to use it that much, which is called Stringer. Stringer is a package. And if we would want to remove this trailing bracket, we can use, let's just copy paste stuff because it's easier and faster. Actually, yeah, we want to recode something, and I haven't shown you the tidy way to do it, but let's, oh, I'm trying to just copy this. Okay, no copying. I'm going to write it from scratch. So Latin name is the variable you want to change. You want to remove the trailing bracket. And there is so every stringer function starts with str. And we can say string remove. And here comes the variable they want to change. So in this case, it's penguin's Latin name because we want to change this. And then we say simply string remove bracket, right? Again, we have to comment it out because the bracket is a special character. But if we do that, it doesn't work because, what did I do wrong? Place. Oh, I called it penguins. Sorry, it's called penguins clean, of course. Again, everyone makes errors. This is very common. I want to really normalize that. And it says object penguins not found, right? Sometimes you have to search for it in the arrow. And of course I wrote, that's why I like to copy paste things because I always kind of forget what the object names were. And if you copy paste it, you don't have the arrow. All right, this should work. It does, no errors. It's always great if you get no errors. You know, there's a certain feeling of success you get. All right, and now the Latin name doesn't include the trailing, right? So stringer is a whole new thing. We won't get into it too much, but it's really useful. And there's a lot of things to do to manipulate strings, like to extract certain kinds of text from text, right? It's really, really useful. All right. There's also a function called unite. This works in the opposite direction. We're not going to talk about it now because we don't have to unite things, but you can kind of like paste them together, paste variables together. We could recreate that again, but we don't have to do that. All right, so now our data is pretty much in the tidy format, right? And we were in luck because the data already came in that format, right? It already had like one observation per row, right? Every penguin was in one row, but sometimes they don't, right? And here's where two variables come in called pivot wider and pivot longer. And they are kind of meant, for example, especially pivot wider is meant for making variables into this one observation per row kind of data set. So we already have this in the format. The penguin clean is already tidy. That's why I created a data set that isn't tidy, and it's actually an example from before. Data set called untidy animals because they're not tidy yet. And this is again a data set where we saw this already. There's a variable that specifies what kind of variable there is inside, and then there's a value attached to it, right? This is also called a long format, but it's not a tidy format. So let's actually keep this open because I want to look at it. So the function pivot wider takes two arguments. It's the names from and values from. It takes more arguments, actually. There's always more arguments, but these are the main two arguments. And you can look this up in the help file. And names from, it tells the functions where the new column names come from, right? So we want to actually have those. Again, we have one variable called lifespan, one variable called ratio, or what I want to call it. And the other variable says, or our argument says, where should the values come from? And if we do this, let's remove this real quick and not assign it yet. So the first argument is a data set. The names from are the type, right? So these are the variable names that we want to later have. And values from, in this case, I already called value, which is useful. These are all the values that should be assigned to those variables. And if you run this, we actually get one animal per row and a variable called lifespan and ratio, which has those values, right? So it takes them and makes them from long into wide. In this case, long into wide means also we're tidying it up. Right, so it's assigned to tidy animals because there's also pivot longer, and sometimes we do need data in long format. For data visualization, that's often the case. That is something that's very useful to have. And pivot longer works with, there's one main argument, which is called colds. And these are just the columns that you want to put into the long format, right? So for example, in this case, there's only two variables really want to put in the long format, which is lifespan and ratio. There's only two variables that exist. And if you run this, we get the previous data set back, right? So it gets a new variable called name. Here's all the names of the variables, and here is the values that are associated with it. And of course, always two rows for each animal. For data visualization, sometimes this format is better, but we're not going to go into data visualization here. But now you've learned how to use it. All right, let's go to the next package of the Tidyverse called Dplyr. And Dplyr really is the workhorse, sort of. And so you can't really see the image that well. It's not that much space. Can I go smaller? No, it doesn't zoom in. Okay, but anyways, Dplyr is the workhorse of the Tidyverse package. Like, this is really where you get all of the data manipulation stuff. If you want to recode variables, select them, filter them, there's so much stuff you can do with it, and that's the core of it, I would say. Well, of course, there's many more, but it's the core of it. All right, let's talk about some functions that are within Dplyr. So one function is select, and it does what you might expect. It selects variables. So if you look at this little scheme here, you can see that we have a data frame that's rectangular, and we only want to keep the blue ones. So we only have 3 rows, right? That's what select can help you do, right? It selects columns, right? Sometimes there's a bit of confusion, but it selects columns basically, or variables. Again, data is always the first argument. There somewhere here as well. I mean, it's either data or vector sometimes, because sometimes like the stringer functions always apply to a vector of strings, right? Not necessarily directly to the data. So it's always the object that you want to manipulate first. Maybe that would have been a bit better phrase. All right. So let's select some variables. Again, penguins clean comes first. And then we can just have a list of all the variables that we want to select, right? So we say individual ID, sex, and species. And these are the 3 variables. Sorry, I'm scrolling so long. But it only selects those 3 variables, right? Straightforward. But that's not the only thing you can do. You can also remove variables. So if you put a minus in front of a variable, then actually removes that variable. And notice again, we only have to specify the name of the variable. We don't have to do $signs and so on, right? This also shortens how much code we have to write. All right, so if you want to remove individual ID, sex, and species, you just write a minus before each of these, right? And run this, and it's actually not super straightforward to see whether it has been removed or not. So let's do a quick. Again, actually, this is really important because, like, how do we check if this worked or not, right? Oftentimes you have to. So let's assign this to a test thing. And we can remove it later if you want to. But had these actually been removed, so we can, for example, run test names. I'm sorry, names over my test, and then I can see, well, does individual ID still occur? Yeah, no, it does not, right? So it's really good to always check whether the data operation you've done actually does what you wanted to do. Good general kind of thing. And if you're unsure, check it after each one. Totally fine. Sometimes you're like, okay, I have to done this a million times. It's gonna be fine. And totally, like, I've done it probably a million times, but sometimes it's still not fine, right? So it's always good to check. Always good to check what happens after you've done a function and if it has done what you wanted to do. All right. So what select can do even much more. So there's selection helpers. And this is a range of variables. There are a few more, but these are the most common one, that you can give it a pattern of variables to select from your data set. And this is really useful because you can say, for example, give me all the variables that starts with a certain string or a certain character, or ends with a certain string, or contains anywhere within this character, or matches. So matches, you can use a lot of regex. So this is what we saw earlier with the unquotation marks and so on. We're not going to go into that, but know that it exists. So for example, if you want to keep all variables that start with S, we can say select, again, data set starts with S. So and this actually matches all of the variables within our data set and start with S. And in this case, study names have the number species sex. Worked as intended. Is there anything with T? There's nothing with T. It's a warning. There's also warnings, which is, it just tells you something is not working. Nothing starts with T. Do we have I's, I guess. There's 2 variables that start with an I. That's island and individual ID. You can also do, of course, doesn't have to be a single value as well, right? You can just do IS. In this case, it would only match island, right? So this is really, you can see this can be really powerful. And of course, what you can also do is you can combine it with others, right? So you do a comma, and then just add, we just add other variables as well, right? So we want to have everything that matches S at the beginning, but also individual ID. And for some reason, it doesn't execute as fast as earlier. Because Google Colab does that sometimes. Okay, well, then I just have to trust me that this works. Can I stop it, or are you running? Can I remove it? I mean, this is good debugging for when you encounter that error. Okay, I can remove it. Can I now do it? Okay, sometimes errors happen. It's very normal. Do a little bit of debugging, try to figure out what's going on. Try and restart it. good computer. This is a good computer. How's it called? Yeah, computer tip. Just restart it and then it works. All right. So there's more ways to select. This one's pretty simple. you can say select the first 5 variables, right? So, we actually haven't talked about this yet. So if we just want to have remember we did sequence, and we had like a vector from 1 to 10. There's an easier way to do it actually. You can just say, we use a colon, and the colon stands for until, right? So do 1 until 10, and then it gives you a vector back that is 1 to 10, right? And it always increments by 1 as well, though, right? So there's can use sequence if you want to have a more complex sequence, of course, but this is something you can do. So column is until, and it's when I select the first 5 variables, you can just say 1 to 5, and just selects the first 5 variables. Scroll up. You can see that only the first 5 variables have been selected. If we want to select from and to specific variables, let's just actually look at the data set so I can show you exactly what it does. So here's the data set again, and we want to select everything that's from individual ID to flipper length, right? You can just say, you can actually call the variable names and say from until with this column. Super useful when you just want to have a subset of your data set. And again, you can just add more, right? You can say comments, which is the last variable here, and it should also add comments at the end. In this case here. Great. Filter is another function that's very useful, and we've done this before with indexing, but filter is kind of more straightforward to read. What does filter do? It filters a data set. And filtering is to be understood in this case for rows, right? Selectors for columns, filters for rows. And as we see here, we want to keep only certain kinds of rows, and for example, only have 2 in this case. So if we use filter, we use a data set first, and then we provide a logical test, right? So this would be the same as with indexing, just we have the logical test within the function. And we say island equals dream, which is one of the islands that the penguins live on. They live on a dream island, which is of course really nice. So, and then we only keep the columns that have island and the dream as an island, of course. Sorry, the columns, the rows. Now I said it wrong. All right. One way to test this, we can nest this real quick and say table. By the way, this is a data set that comes out of here, right? So technically, what you can do, and I don't recommend this, and we won't do this that much again, say $ after this and say island, right? Because like this is just stand-in for a data frame, right? It doesn't have to be a single object data frame. This is already a data frame. You say $island and table. Doesn't work. Why not? Oh, because I forgot a bracket here. And actually, again, oh, I see where you found that error earlier. But this is actually, right, a lot of this nonsense, right? The actual thing it tells you what we have done wrong is unexpected bracket that is closing. So that means there's no opening bracket, right? You get used to some of these errors, right? But again, very normal, happens to everyone. And then we can see there's only the dream variables in here right now, right? By the way, I'll just show you like what the equivalent of this is in case this is confusing, right? So imagine we have a new data set, assign this here. Sorry, one was there. And say table. Oh, sorry. Yeah. So we assign, to this an island. This would be the same. This would be the equivalent, right? I just nested a lot of it, which is not a thing you should usually do. All right, quick XCourse. So let's remove this again. We can also use in variables, and here also the in operator. And here again comes a really nice use case of the in operator, because we can say, well, I want to only keep the islands of Dream and Bisco. I'm sure I'm saying this wrong, but Biscuit, I don't know. I'm saying this definitely wrong. Sorry about that. But you can assign this to a object, your vector of islands to keep, and then you can say filter the penguins, your data set, islands that occur within islands to keep, right? So this is a really useful way to filter your data set to only these rows. And it kept the Bisco, or also the Dream Islands, right? You can see that here. Great. Let's get to Mutate. Mutate is there to create new variables. So the way you do this is you write the function mutate, and within it, you specify the new variable name, and it says equals, and whatever sum calculation or any kind of other value that you want to assign to it. So let's try, he says it's tail, I should say, we take, of course. We take the variable body mass in grams and want to create the same variable in kilograms, so we can just divide it by 1,000, right? So mutate, first function is the data set, first argument is the data set, then we give it a name, right? The name comes first here. We want to create the body mass kilogram by dividing body mass G by 1,000. And this creates the this variable within the data set and hangs it in the end, right? So it's going to assign this to an object just to check whether it actually worked. And select, I'm just going to select it in this case, because that's easier. Select the data set, this new data set that we created, and only keep body mass kilogram and body mass gram. So we can directly compare it. This should be fine. And ACE, by the way, I just kept as they were. They just are ignored. Well, most functions do that. It's just a standard for a variable. All right. Now we'll get to recoding with else. If else is a really useful function, and it's actually a base R function, but it's super important, very easy, or very important to use for coding binary variables. And oftentimes you want to do a binary variable. So the way if else works is it's a function. The first argument of the function is always a logical test. So equals equals or something like that. And then the next thing in if else is what should happen if this evaluates it true. And the next argument or input is what should happen if it's false. And then it returns that, right? Depending on what the input was. So very basic example, let's say we have this logical test, 1 equals 1, and 1 does equal 1, of course. But in this case, if it's true, then pick me if this test is true. And then it would output pick me if this test is false if it evaluates the false. In this case, of course, we can see 1 equals 1, so this is true, and it gives back a string called pick me if test is true. If we say 1 does not equal 1, it should give us a second one, right? Because that is the condition, or if that condition is false, then it should give us a second thing that we put it in here. And in case you were wondering, it does do that exactly if we say 1 does not equal 1. Okay, we can use if else in combination with mutate. So we can, for example, create a variable called sex short, which just has shorter labels for sex. And sometimes it's useful for a graph or something if you don't have the entire name there. And we would use mutate, the data set again, give it a name, which we decided to name it sex short, and say if else, if sex equals male, which is how it's coded in the data set, then assign to it M. And if it's not true, assign to it F, right? Let's actually also use select again, because that's one thing I often do. Just call it PG new and select PG new, and we select sex and sex short. And then, of course, we have to create this first. Right, so we can see what we did here. It's a bit annoying, it always creates this long thing. But now we have the sex variable in capital letters, and here's a shorter label of it, right? It is a very basic operation for if you want to create a binary variable or something that, you know, if you only want to change one value or the other, right? No, it actually will not put the NAs as F because it'll ignore that. That's pretty useful, right? So we could also specify exactly what it should do with the NAs, but we don't have to with else, right? So we can see here it says NA, and it will kept as NA, so it just ignores that. But we're actually going to learn now how to specifically also code for that. So case when is kind of like if else on steroids. So you can do a lot of logical tests and a lot of conditions and test, multiple conditions basically. So the basic template of a case when is use the case when function. You open it up, and that's also like how it's used. So you open it up. It's kind of like a function. It looks a bit like a function, but it's not. Or like the function creation thing that we did. But the first thing we're going to do is a logical test. Then you use a tilde, a bit awkward sometimes, but that's what you use, and say what should happen if true, right? If this evaluates to true, only this, then put in the value that you want here, basically. And then you can stack them, right? You can do a lot of these things. And the way case when works is always grasping up from top to bottom, right? So if you say, say we have a logical test and multiple things, let's say, how can I do this best? Maybe it's best when I show it later. So let's keep this around and I'll show it with the data itself. But you have all these conditions after each other. And in the end, there's something you usually do and say true. So this is just always true. This is what should happen with everything else, right? So these are all the things that you tested. Imagine these are all small if else's, right? And for everything else that didn't test positive, we don't have to test false necessarily, right? For everything that didn't test positive before, you assign them as every whatever you want to assign, some default value or something. Okay, so let's try this out with a vector from 1 to 50, from 1 to 50, sorry. So this just creates a vector from 1 to 50. I'll show it to you real quick. Let's separate these out. So use a vector from 1 to 50, and we can say, okay, case when. If x occurs in the range from 1 to 10, then assign it to 1 through 10. If x occurs within 11 to 30, then say 11 for 30. And then true, that's for everything else, say above 30. Does case when if else work with replacing or adding a new variable with a data frame? Yes, we're going to do this. We're going to do this in a second, yes. If we run this, we get a vector of the same size. And now every number that is 1 for 10 gets the 1 for 10, and everything that's 11 for 30 gets 11 for 30, and everything that's above 30 gets the above 30. Pretty straightforward. What I wanted to say earlier, and it's better with an example, is if I have a condition here that has already been met, right? So 1 to 10 has been met for all values from 1 to 10. But now we could say, from 1 to 10, from 1 to 30, assign 11 for 30. What happens now? Well, case when always goes by the one that has been matched first, right? So if 1 to 10 has been matched for this, it won't match it again for the second one, right? So this is an important kind of thing to know about it. So if we run this, it gives us the same results, right? So 1 for 10 is 10, and then 11 for 30. So it doesn't reassign the 1 for 10s to this second condition, right? So it always tests in order. If it's already been grabbed by it, it doesn't do it again. So if we had 3 different values for sex, in order to make them sex short, we'd have to use case when and not if else. Correct. So, I mean, we don't have to, of course, right? But if you don't use case when, you have to do an if else, and then within the if else, you have to do an if else. And that gets really annoying. So you don't want to do that. So yes, correct. If you have 3 different values for sex or more, then you would actually have to use case when, or you would be as wise to use the if when. And I'm going to show you another logical operator I haven't shown you yet, which is an A. So if any of the values is an A, you can test for it by saying is.na, right? So if x is an A, then also give it an A, I suppose. Or let's call it missing. Why not? And let's add just a missing value here. So this is just a vector, right? Just we add a missing value at the end. So here's an A. We do this and we say if is an AX missing, and we should see at the end a missing, right? So here we can explicitly also code the missings, but we don't have to. How many conditions you can stack of case when? How many your computer can muster. Like you could just do whatever, right? You can just copy paste this into infinity, basically. Not that you would do this, but sometimes it's very complex things that you want to code. All right, so let's combine case when with Mutate, right? So the way you would do this, and then I did a little bit of indexation, so indenting, so it's a bit more readable, right? So we take the first argument as the data set, then we want to create island short in this case. And island, of course, is free values, right? So this is, again, a sex question. The island is a good example because it's free values. So I want to say island short equals case when island, and notice again, we don't have to do the $, whatever, it just automatically knows that is within the data set. We say island equals Torgerson, assign it a T. If island is Bisca, assign it a B. If it's dream, assign it a D. Since there's only 3 of them, we don't have to say the true equals whatever, right? We could do that just to be sure, right? But we don't have to do that. And again, it's good to test it. We shall do this and say select test island short. And of course, you can see that this worked as intended. Right. You can also mix different variables, right? You can, this can be a very powerful tool actually, right? Like this is only scratching the surface. We could also do, let's just try this out real quick because we have a little bit of time. We can say if island equals Torgerson and sex equals male, then it's T plus M. Somewhere TM. So why it's changing color? Shouldn't do that. Confuse me, but it doesn't matter. And if it's female, do TF. Right? So you can mix all of these conditions as well. And yeah, because something is wrong.
Die Gänsefüßchen bei Mail fehlen.
Oh, thank you. And that was in German, but I do speak German, so that was good. And by female, of course, as well. See, this stuff happens all the time, and I'm not doing this on purpose. I wish I could say that, but you'll miss things like this, right? What's the error message actually? Do we have to deduce it from the error message? Okay, it says unexpected symbol, right? So that is like, well, what does that mean, right? But yeah. So, but you notice how I noticed it though, like how I noticed that something was off at least, because the syntax highlighting didn't work, right? So that's another good indication. Like, right, so normally it would. It went too much back. Yeah, the index highlighting was off, right? So here, it's like this should be the same color as up here. So why is it not? So yeah, that's the way to do it. Okay. And this should have worked as well. If we say test, assign this to test, and select both of these, and you just have to find examples within this long data set. Yeah, here, right? So this should be fonts, right? And the one that are in A are kept in A. Actually, in this case, there's a bit more complication here because like the island is not in A, but the gender or the sex is in A, right? So in this case, it just makes it all in A. So we have to account for that. But I guess it makes sense because like only if sex is male, then do this. And sex what he would have to do is say if sex is an A, right? So if an NA sex, then say T and A, right? Makes sense, right? It couldn't match it because it wasn't male or female, it was an A. So if you go all the way up, it should also have that. Great. So we did some very complex case winning here. Can't get much more complex than that, but that's already fine. Okay, let's keep this for now. Next is something more easy. Let's just simply rename. And rename does exactly what you think it does. And that's also the beauty of these tidy functions. They often just do exactly what you think they would do, right? And then that's why I really like them. So if you want to rename a variable, use the data set first. And similar with mutate, just in this case, you don't create a new variable, you just rename it. You say sample, that's a new variable name, and say equal sample number, which is one of the names within the data set. And in this case, we scroll up. The sample name is not here. Well, I can just do $name, and it will show. Oh, sorry, same sample. $sample. Like this variable exists now, right? But what the other variable that does not exist is sample number. Right? It doesn't exist anymore because I renamed it. It's a quick way to do it. So yeah, I mean, I use tidy like syntax often, but you can also combine whatever you're doing here with base functions like $, or indexing, if it's more convenient, like in this case it was. Another very easy function to use is arrange, which simply just arranges your the data set by a specific variable, right? So if you order by flipper length, we can say arrange the data set by flipper length. And by default, it arranges in a ascending value. So the short values first. So we go to flipper length somewhere here. You can see it sorted it by the lowest flipper length. So 172, and then it gets more from there, right? You can also sort by multiple things. So you can also say sort by sex as well. So actually, you would first want to sort it by sex to make more sense. And then within the sex, you want to sort it by flipper length. So if you go up here, just look at it. So this is flipper length. This is the lowest female. And if you scroll somewhere down, male should appear. I think this is, yeah, it's truncated here, right? So we don't see, maybe, we don't know if this is the lowest for males, right? But trust me that it also sorts it for that. Okay, so we can use multiple ones, as many as we want. Some of them won't make sense at some point anymore. But this was ascending, right? But if you want to do descending, so the higher values first. By the way, yeah, you can also, if you sort by categories, of course, it sorts it from A to Z, right? So just the alphabet. Okay, so if you want to have descendant values, we just use the function descendant before we pass the variable that we want to sort by. So arrange penguins, and then say this desk or descendant, the flipper length. And that should give us the highest flipper length values first. Oops, sorry, scrolled up too much. Yeah, this is not the best way to show it, I'm sorry. But if we go to flipper length, the highest is 231, right? And it goes only downwards from there. Okay. All right, so far we only looked at functions that kind of keep our basic data structure intact. But the functions from Dplyr can do more than that. And one such function is called group by and summarize. And group by and summarize actually changes the structure of your data set and brings it to another level in some case, or in some ways. And it's basically for aggregating your data. And this, for example, creating group statistics like a mean per group or a median per group, or the first value per group, the last value per group, the highest value, and so on, right? So you can do a lot of like summaries, but it actually changes the internal structure of your data set. And in other languages, I would say this is often a pain to do. Like if you do this in Python, it's not straightforward sometimes. At least, I don't know much Python, to be honest, so I don't want to make this strong. But in my experience, let's say that, it's not as easy and straightforward to do. So, and in here, I think it's really easy to do. And it's also that I can say for certain is that in R, doing a calculation by group is also kind of a weird thing to do and not super intuitive. But this really brings it to another level, which has variable names that actually correspond to human language in some way. Let's say that. Okay. What happens? Well, we have some kind of group, and in the end, we have some kind of summary. That's what group by does. And this will come more clear momentarily. So let's say we want to calculate the common length for each sex, right? What we would do is first group the data set and group it by sex, right? So we use the group by function and say first argument again, data set, group it by sex. Then we have a new data set, and actually this data set here looks entirely the same as the data set before. All it does is it doesn't show up in Google Colab, but like in R itself, it would say group by, right? So this is a group data set, and you can think of it as kind of marking it, right? So it doesn't change directly the data set, like it doesn't change the rows or something. It just marks the groups. So future functions know what the groups are within this data set. And so we create this grouped data set, right? Which is just a marker, sort of. And then we use summarize, and summarize we can use in the same way as you would mutate, right? So summarize, you have a variable name and then some kind of calculation. But in this case, we do the calculation by group and not just by the individual row. All right, so you summarize, we use the data set. So we use the data set we created up here and say average common length millimeters. This new variable name doesn't exist before, is the average, equals the mean of the common length. When I said earlier, most functions kind of ignore NAs, that's not always true. So it's good to check. And mean, for example, doesn't ignore NAs. So one thing you have to do with mean, if there are NAs, you have to say NA.remove equals true. And by the way, I'm not sure if I mentioned this, but you can shorten true, so this is the same, to just T. And you can shorten false to just F, right? Just a shorter way to write things, but we don't have true here. I'm going to show you what happens if you don't have this, because then you recognize it when you forgot it. And I forget it all the time, so it happens. Now I'm again surprised by something. I feel like I should have given you NAs here. But maybe this is a new R version that doesn't like behave in the way I am used to. But normally this should give you NAs. Like it doesn't calculate it because it doesn't know that it should remove the NAs. Maybe it does it differently now. So maybe it's not needed, but it's good to know. I'm getting surprised by functions. So you know, I've been using R. I haven't mentioned this. I've been using R since 2012 maybe, and I've only like really understood it in the last 3 years or so. And I still get surprised by things, right? So it happens. Why should you use a group by function and not just create a new categorical variable for it, or one binary variable for each group? What's the advantage? Well, how would you create the statistics by group then, right? Like the group by function is necessary for calculating the statistics by group, right? The group by function on its own doesn't do anything, right? You can create a new categorical variable, of course, but that's not the purpose of the group by function. The purpose of the group by function is to mark the groups so that future functions like summarize know that they should use the operations by group and not just by row. That's the difference. All right, so enough played around and learned new things. All right, yeah. Anyways, so here's the average common length per female by male and for all DNAs group as well. And of course, yeah, we can see that males, for example, have a longer average common length. Of course, we would need to have some statistical models to really prove whether there's a statistically significant difference, but we're not going to go into that here. All right, I think this is a really useful function to calculate group statistics. Right, we could also do median. And we get the median common length. We could also do, let's just change the name here because otherwise this doesn't apply. So new var, whatever that will be. We can say, what can we say? Min. So for each sex, give us the minimum value. And that would be 32 for females and 34 for males. Or we can use max. And in this case, it gives the maximum value per sex. All right, just peeking on the questions, because there are some. Can we match it back as a column in the DF? Yes. Well, the thing is, of course, like this now, like the summarize function, no, because the summarize function actually changes your data set into a new data set, so to speak, right? So it's a different level. Now it's on the level of it's grouped by sex, right? It's not grouped by penguins anymore. What you can do, and I'll show this really quick because it's actually interesting, of course, as well. Once we've grouped this, it doesn't only apply to summarize, of course. It also applies to mutate. So if you do mutate and say, yeah, just copy paste this exactly. So we create the average common length by calculating the mean, right? And this will now happen by group, right? But we will keep the structure of the data set. So we'll still have 344 penguins as we had before, but at the end of it, we have the average common length. So of course, this means that if it's the same sex, right? In this case, it's the same sex. I'm sure which, it's female. It has the same value, right? So this is how we would attach it to the same data frame. Yes, so it is possible, but we have to use mutate instead of summarize. And of course, we have to use it on the group data set. Yes, so another important thing, if you've grouped the data set, it will always do this, right? So you don't want to run a function that you don't want to execute by group, right? So this could lead into some weird things. So you definitely want to ungroup after you've done, and if you're done with this function. An ungroup is just a function that removes this marker of the group for your data set, right? And it's the same data set again. There's nothing new to it. You won't see nothing added to it. It just removes this marker of the data set. All right, but in this case, we're not going to work anymore with this group by sex data set. But if we were, we have to ungroup it at the end. Okay, so another question. What is the advantage of group by function over subsetting? Not sure what you mean by subsetting. Like, I feel like subsetting does something else, right? Because like the group by function marks the data set so that you can perform operations afterwards. If you subset it, you can for example, subset just for sex, and then you can subset it just for female, and then you can just subset it for when it's in ace values, and then you can execute the function for each group separately. But that would mean a lot of filtering, a lot of separate stuff, and then you have to combine it again, right? So I don't think subsetting isn't. You can do it via subsetting, of course, but that would take a lot of different, the more code. And subsetting, I think, yeah, it doesn't directly do this, right? But you can use it in a similar fashion, just much more tedious, I would say. Okay. Another function that I use all the time, and this is really useful, and I kind of like my hands ached all the time to kind of use it, because it's really useful to just check what the values of a function are. And it's kind of like a table, but within a tidy context. So the first argument is always the data set. The second argument, second argument is all of the things that you want to count. So for example, I want to count the frequency of species in our data set. And we can also say sort equals true, and then sorted by the highest frequency, right? So it's kind of like table, but a bit better. I do it all the time to just see what kind of values are within my data set. So in this case, we have the Adelaide pangolin, and this is the highest occurring penguin in our data set, and then right, sorts it by it's kind of useful. We don't have to do this, right? So you can just do this. But we can also count multiple things at once. So we can say we count by sex and by species, right? And also does that, right? So these are functions that kind of change the entire structure of your data set. All right. Okay, we're almost there. And we're all right-ish in time. That's good. Good. So I talked a lot. Hope you were able to follow also in the Google Colab. Let's get to the pipe operator. So far, we've used the Tidyverse in a way that it's kind of not intended to be used. Sorry, I'm scratching it. Okay. So it's not intended to be used. The pipe is really the core of how the Tidyverse should be used. And I'm going to show it to you in a second what the advantages of using a pipe are, but it's not something that you necessarily have to do. It's kind of like just the intention and recommendation of how you have to do it. And then feel free, like in the exercises later, to kind of play around with this and then like really try out whether it feels right to you. Or maybe sometimes, I think like sometimes people think like it's confusing for them, and that's also fine, right? But like that's kind of the how it's intended to be, and then just try it out a little bit, and you'll find your way within this. All right. So the idea of the pipe is that you read from left to right and from top to bottom your code, right? So in a way, we can already do this without the pipe. So we can say some of the stuff we did before, right? So we can say first you select some variables, so use the data, and then you select 3 variables within it, right? Assign this to a new data set. Now we have only a data set with these 3 variables. Next, you can filter it, right? So I want to only keep the penguins from Dream Island because who wouldn't want to keep the penguins from Dream Island? This seems like a good place to be. And then you convert the body mass in grams to kilograms because that's just easier for you. And we do the mutate. And then we rename individual ID to ID because it's shorter, and why not? So we can do this, and this is fairly straightforward. And readable as well, I would say. But one thing, of course, is, and we can just execute this PG code and see that it did the things that we wanted to do. Rename the ID and so on, kilograms, and so on and so on. Now this works, but it's a lot of repetition, right? So you're repeating the data set over and over again. You're assigning it over and over again. Another problem I see also with this is PG is just what does PG stand for again? It's just penguin short or something, right? Whatever. It doesn't have to stand for anything. Just how I named the variable. So the thing is, you're assigning a new variable, and sometimes when you're within a data pipeline, you're like, okay, now I did this, and then you're overriding the object, and you're like, and then you want to do something, but you didn't notice that this isn't the data that you actually wanted to have because it's always the same name, right? So override it always the same name, and you might get confused where exactly you left off the object, right? And that's something that with pipes doesn't happen as much. Now there's another way to not repeat the data set all the time, but it's certainly not the recommended way, which is just nest all the functions, right? So we can just say, and it's really hard to find out, but so since like the idea of ours, of course, everything that's within a function gets executed first, right? It's kind of like a mathematical rule as well. So you can say, I want to only select these variables, right? Then this is itself a data frame that comes out of it, right? So you can say filter this data set, right? And island equals dream, and so on, right? So we know how to select everything and mutate it and rename it. And you have a bunch of like arguments afterwards. That's not readable, right? So you don't want to do this. Okay, so the thing is like, you don't want to do this, but like oftentimes before I also know the pipe tidy approach, I often did this. And then your code doesn't become readable, right? Because it's from inwards to outwards, like that nobody reads this way, right? Like it's really difficult to figure out what happens here, but also if you want to debug it, like where's the error, right? Like there's an error that occurred within here. Where would it ever be, right? You don't see it directly. And let's go to tidying, to the piping and how it actually works, right? So the pipe, this operator here, is read out as and then, right? And now I think really the idea of naming functions as what they do really shines out here, because you can just say, you can actually read the code as would a human would read it, right? You can say, oh, sorry, okay, the pipe is important. And also the pipe puts whatever you piped to the first argument of a function, right? So first argument of a function, I said this a lot. Why does it do that? Like every function in the Tidyverse works this way and really allows us to create these pipelines. So if you would read this code, we would say, take the data set penguins clean, and then select individual ID island body mass G, and then filter island to only dream, and then create the variable mutate. In this case, you could maybe call create, but mutate is a kind of a weird word. Anyways, mutate or create the variable body mass kilogram equals, or that's how it's calculated, by 1,000, and then rename ID, or in this case, it's actually the other way around. Rename individual ID to ID. Not perfect, but still very readable You can read it from top to bottom, from left to right. And actually what you can do, if an error occurs anywhere here, you can just comment out any single, you have to comment out the pipe as well, but you can comment it out. And then you can like check each row what's actually going on, or yeah, for each row what's going on in your pipeline, right? So let's say there's an error. Let's actually do this real quick because I think it's important. Let's say I forgot the quotation marks, which is something that happens all the time. And now I execute this. I'm like, oh, what is this? Unexpected incomplete string. This is actually a pretty decent error message, right? But like maybe I don't know what this means, right? So I can just say, okay, well, I don't know what this means, but I can just comment out the pipe step by step, right? So I now execute this. Okay, same error. Where is the error, right? Now, okay, I can keep this out. So let's do this. And, oh, sorry, let's comment out this and this, and also the pipe. And now it works, right? So it means the error has to be somewhere here, right? And now I can further examine what I did wrong and maybe noticing, oh, I have the quotation mark missing, right? So what I really like about the setup is you can see for each row what's going on. There's one operation per row, right? And you can actually read it from top to bottom. And let's remove the hashtags here, of course, so that the code can run again. And of course, this is a ready pipeline, but it doesn't start out this way, right? So if I remember, yeah, I mean, we can just, like the way you would do it is, of course, use the pipe, and then you say select, and say ID, individual ID, that's one of the things. I didn't write it correctly. Yes, I didn't. Individual. Right? So you would write it from scratch. You do the first thing and you do the second thing, and you always test it out, right? And then you do this, and you can use indentation, and it's recommended to use indentation, but it would also work like this. But it's not recommended to do it this way. All right. Okay. So there are some exercises soon, and we are running a bit short on time, so we do want to get to them. Oh yeah. You can also let's just the group by real quick. So we use the penguins clean, group by sex, and then summarize by average length, right? So here, not a really easy to read like what you're doing, right? You're using it as a data set, you're grouping by some kind of variable, and then summarize it. When creating variables, it's common to use equal and not. Would it still work? No, so the equal sign does not work within a function. Sorry, the assignment, the arrow does not work within a function, right? Within a function, you always use the equals. That's a good to separate those two, right? All right. A small note in the pipe, since the latest version of R, which I haven't installed yet, so maybe it shows already, there is a native pipe in R, so you don't actually have to load it in via the Tidyverse. It looks like this. There's some differences with it, so we're not going to use it here, but it works kind of similar. There's a lot of overlap, but there's some of it that doesn't work the same way. Can be confusing, so we'll just stick with the pipe as it is in Magritte. Okay, so let's see how we do this best, because we don't have that much time, but I do want to have you work a little bit on the tasks. And let's say, I do want to also have a bit of parting words in the end. So let's do 10 minutes, and this is too short, right? So don't worry about it if you don't get to the end. I'll show you the results at the end, right? And then you'll have it as well. I have a finished version with all of the exercises and so on. I'll have that also posted somewhere, so you can actually also check what the results are of these exercises. But I do want to have you play out and solve kind of tasks yourself, because like one thing I find is you don't really learn it until you've bashed your head at least 5 times. That's unfortunately often the truth. And but I'm definitely also here to try to help you to bash your head a bit less often than you would normally have to. So sorry, that wasn't too healthy of a way to say it. but I hope the message came clear. Okay, so it's try to get the exercises. Yeah, that's it's here. And here's a references of all the functions in case you lost track, because there's a lot of them. And some of them are super easy, but more difficult. Others, if you feel like one is too difficult, just skip them. All right, let's do 10 minutes until 2 p.m. and then we're back. Alrighty, stop sharing my screen, see if there's any questions. Okay, there's a question about, I think also you were using read CSV, because I think that that's how it works. So there's a question about reading in data and R automatically parses the data based on what it thinks it would be, right? So and then this person received a lot of parsing errors because it didn't guess correctly. So I think you can pass, as you said, you can pass the values manually, but and that's a way to do it. It's a bit annoying, of course. But what you can also do is once you have loaded them in, just change the type, right? And then that's just part of data cleaning, right? There's no straightforward answer, I suppose, to this that makes it easier, right? So either you directly specify it as what it should be read in, or use any of these kind of tidy functions to to change the what the type of the data that it should be. So the data is not lost when the parsing errors occur. Well, it depends on what exactly, right? Like in your case, I suppose you said parsing errors. So it's missing values and it's actually dates. So I assume what would happen, and I'm not 100% sure, you should check that. I assume what happened is, no, in that case, it is lost because it thinks it's a logical vector. If it's only an ace, then it thinks it's logical. So it would be lost. Yes, correct. All right. Yeah, exactly. So they would be lost in that case, unfortunately. So we would have to have specified manually. There's unfortunately no easier way around that. I'm already solving the things in the background, so we can quickly move beyond that. Okay, it's 2 already, 2 p.m. or 10 minutes have passed. I realized that you probably wouldn't have come that far. I don't know, can we go a little bit over time? What do the organizers say? Or is that a huge problem? So I'm not sure about that.
I mean, how long over time?
No, I mean, maybe like 10 minutes max.
Yeah, of course, sure.
Okay.
Yeah.
All right. Good. I can deal with that then. Good to know. All right, so I'll just finish something real quick and then you have a bit more time. No, I'm not gonna keep you hours here. I get a strange error message for task 4. Error can't rename columns that don't exist. Well, in this case, it seems like you're trying to rename a column that doesn't exist. So did you check? Maybe you would change. So that's not a common thing and happens to me all the time. Is also that you try to rename. So you have to put in the name, the new name first, and then equals the old name. Maybe that fixes it. But in this case, yeah, something. The variable name you're trying to create is not the same as you think it is. Let's do 2 more minutes then. And we probably won't be able to go through all tasks then, but feel free to do them in your own time. All of the tools that you need for them should be in the script, right? So there's nothing new. There's a bit of like the same trick but a bit differently, right? But there's nothing. It should be too complicated if you, try a bit. But of course, feel free to reach out. Like I'm definitely like for this, I'm absolutely available. Like if you need any help with any specific words. Okay, let's go over the exercises. We might not do everything. Yeah, no, we might have time. All right, let's try wing it, and I don't want to keep you so much longer here, because I mean, there's only going to be like after we've gone through the exercises, it's going to be some final words from me, and I wanted to give you the opportunity also like just maybe ask some questions, of course. So that's fairly important, of course, to me as well. You have the opportunity. Okay, Let me share my screen. Okay. All right. So load the Tidyverse and janitor packages was the first task. Pretty straightforward. Just load them. Show why it's like running that long again. Sometimes bugs out, I guess. Read the CSV from this URL, right? So we've done this before. When we first looked at the Penguins data set, we looked at the raw data set. This is actually the clean data set. Oh, runtime disconnected. Interesting. Okay, anyways, so read CSV. You have the link. It's a bit long, but in quotation marks, and then you assign it to Penguins. And then we just use Glimpse to look into the data set. And it's kind of like a clean data set, much shorter. That's the idea behind it, right? All right. So the task 3 is only keep the variables species, island, and sex. We can do this with the first way we learned it, right? So we use the data set as first argument, or keep also species, island, and sex within here. But we can also use the pipe approach. The pipe works, I'm not sure if I said this, or this is the most important. The pipe works because it always puts whatever object you're piping into the first argument, and the first argument is always the data set, right? That's why it works, right? We could also do, maybe to illustrate this real quick, we can say hello, hell is also good. Hello, and then pipe into print, right? And this works because the first argument just expects it to be a string, right? But in this case, this is more code to write, right? Like this is less code because I don't have to specify, at least in the pipeline, I don't have to specify the Penguins data set all the time. All right, only keep variables 2 to 4, pretty straightforward, just 2 to 4 as numbers, also as pipe. Remove the column year. Remember, with a minus, you can remove columns. So, or as a pipe, select minus year. Only include columns that contain MM in the variable name. They might have been a bit more difficult because you had to look into like the list of the selectors. You can just use the variable called contains, function called contains. It's really useful. Anywhere where there is an MM in the variable, it should keep. If we do this, it's actually free. First, I intended only to keep the things where it says, oh, there's no comment anymore. All right, no, that's fine. So it's all of the variables that include millimeters, right? And we can have this as a pipe as well. Rename the island to location. Very straightforward. Either as we've used before with Votta pipe, about island and location, right? So if you're sure if you wrote it this way, the person had a problem. But first, oh wait, now I did the error, right? So I got confused again because I did this very quickly. We want to have the new variable called location, and the old variable is called island. So I would have gotten the same error as you probably. Let's see. But this really shows, like, I mean, can't rename columns that don't exist. Now, this really shows that, you know, it's a very common thing, and it's very normal to do that. So where was I? Location to island. Yeah. And of course, I got it wrong here as well. Okay, works. Task 5 is filter the data so that species only includes chinstrap. So filter, logic test. We're already experts in this now. Logical test with the pipe as well. Filter so that it only includes chinstrap or gento. I'm not sure if this is the right pronunciations. And here is actually wrong. I have to say this, of course. And you can use the in operator for this, right? Because you want to have chinstrap or gento, right? But we can also combine ands, right? So in this case, if we want to have a male and species addly, we have to say sex equals male and species addly, right? Otherwise, if we say or, for example, we would get either or, and we don't want that. So it would give us either all male or all addly. But we want only the male addlies, and then that's how we would combine it. All right, task 6 is create 3 new variables. It should be build length m and so on, and everything as centimeters rather than millimeters. One thing with mutate, and I didn't show this yet, but I'm showing here, is that you can actually separate within the mutate by comma how many new variables you want to create. So you would say you want to create the build length, the build depth, And the flipper length, actually I should have written down centimeter because it's not millimeter anymore. Same for down here. Yeah, so you can just separate them by commas, and then all of them will be executed. So that's another tidy way to do it. Create a new variable called builddef categorical, so categorical, and everything that's above 80 millimeter and self is high. So do the greater equal sign, I did only the greater sign. The other way around. So this is my code very quickly. And I did make mistakes here, of course. So we use the if else, and we say if builddef millimeter is bigger than 18 millimeters, then it should be high, and if it's below, it should be low. Straightforward. Create a new variable called species short. So here we can use case when. This is pretty much the same process as before. Case when species equals Adderley, it's A, species strap is C. And if you're lazy, and that's what actually I did here real quick, is I just copy pasted the case when from above. So if I scroll up here, and it's good to be lazy in coding. I can totally tell you that, because you want to have the easiest way to do it and not the most frustrating way to do it. Where's the case when? Am I not seeing it? Case when. So you could have just copy pasted whatever is here and only change the variables that you have to change, and then it goes very quickly. All right. Okay, so that's only how far I got. Let's see how quickly I can go this. But like some of them I actually won't do, because then we'll just have to, like, you can do it on your own time again. And if there's a question, I'm actually going to upload a file that has all of the solutions. I think I'm going to take a little bit of time just to find a bit more errors as I'm going through it, right? So I'm going to take a bit more time, and then probably via the organizers, we can send you an email with like, okay, here are the solutions. Here is the code that is empty in case you want to do it again. Yeah, so I provide that for you after the workshop. Let's do until 15, and then yeah, we'll see. We probably didn't get as far. I don't know. Like maybe did, but I did really struggle to get as far as this. And kudos to you for sure if you did that. All right, calculate the average body mass per island. We're gonna group by island. I'm gonna use tidy because I can do that faster as well. And we summarize, and then we're gonna say average body mass. This is the new variable equals mean body mass. I wonder like if it's gonna give me an ace now. It is gonna give me an ace. So you do have to have the NA equals true. I'm not sure what I did earlier on, but this is important. If there is an ace in there, it won't give you the value per group. All right, I did something weird earlier maybe. Then the array, do it with the pipe operator. Okay, so I think the next ones, so this is just creating a big long pipe operation, right? So try this in your own time. This is really where Tidy shines. So this is really a useful thing to learn. And a lot of the code that's out there is written this way as well. So yeah. Could we say R is a language and Tidyverse is a dialect of a language with its own grammar? We can absolutely say that, and people absolutely say that as well. So Tidyverse is kind of a dialect, yes. R is the language, and it's useful to know both, right? So sometimes you have to talk it's interesting. I'm not sure what the term is in English, but in German you say Hochdeutsch or Hochitalienisch, right? So like that is the correct, the grammatical correct kind of way to speak. And then there's also dialects, and sometimes it's good. Oh, standard language. Thank you. Yeah, so standard language is good to know, but also sometimes a dialect, right? And dialects can have their own upsides. In this case, in Tidyverse, I would say it's a great upside to have. All right, so we're not going to go over the other tasks. Definitely feel free to go over it in your time. There's tons of other resources. I'm going to go to my final slides, which are somewhere around. There's a lot. Okay, so I want to show you a bit around RStudio. I'll say a few things about it, but I'll try to be quick about it. So RStudio is the environment in which we normally execute R. And I've shown you quick things here, but just to show you around, like once you've installed R and you're not completely kind of like, what is this, right? So typically there's 4 panes. There's customizable things you can do, but there's 4 panes. On the upper left, there is everything that goes from files, right? So here's your files and your R files. .r files are just files that store R code, basically, right? And that's where you typically would write code in the way we just written code in Google Colab, right? So let's see, 1 + 1, and it executes the code, and actually executes the code in the console, right? So here on the lower left is the console, and that's where the code is actually executed, where you can see it, right? But, or at least, I mean, the code is executed here, but that's where you can see the output, let's say it that way. On the upper right is all of the, there's an environment pane, there's a history pane that you don't use that much. There's actually a tutorial now in the newest RStudio, which is really cool. So you can actually learn how to do stuff within RStudio. So this is really, really cool. Another good resource to learn stuff. I'm going to show you a few in a bit. But here's all the environments you create. And you might have got a bit confused sometimes in Google Colab, because like, what are the objects you already created? Well, in RStudio, you can actually see what the objects are, right? So we'd say important number, let's call it that, I don't know, and execute this, and then it actually shows up here, and it actually shows up what's in here, right? So this is really useful to like look in what are the objects that are floating around, right? You can also cars, I guess. So if there's a data set, you can actually like look into the data set like this also, right? So it's pretty useful as an environment to like look into. And on the lower right, there is your file manager. And there's also more stuff. There's like a file manager. Here's all my R projects that I have, which are a lot of stuff. If you plot something, let's just plot something real quick, then it'll also appear down here. Something is a plot of a vector from 1 to 4, a histogram in this case. You can install packages from here by clicking. I don't usually do that, but you can do that. Help files would occur here, and actually much more nicely rendered within RStudio. And viewer is for like interactive graphs and so on. Like you don't often use it, at least. Okay, RStudio paints. You can also customize it, and I'm going to show you this real quick because I think I can show it quickly. Is like this is how R ships out, but what I like to do is I go to options, global options, pane layout, and actually put the console on the upper right. All right, cool, thanks. We're not done yet, but thanks for a lot of gratitude and thank yous. That's nice to hear. Yes, so where was I? I usually put the console on the upper right because what you can do, you can actually like close these down, and then you have the console on the right and the code on the left. It's really useful. Like it's really useful to like see the code this way, because like typically you don't need to like look at the environment all the time, and you certainly don't need to look at your file manager all the time. So this is like typically how I use R. Again, not a recommendation necessarily, but that's how I find it most suitable, or like the best way for me. And as you can see, I'm still using version 3.63, which I should totally update. Maybe there's some stuff in there that is new and I wasn't aware of. Anyways, back to my slides. So RStudio tour, this is the stuff that I just mentioned. RStudio projects. If we had more time, I would absolutely show you that. And especially if we were using RStudio projects, if you were using RStudio itself, sorry. RStudio projects are an extremely nice way to like sort your code and have all of the environments and like, for example, data sets or images that you save, everything in like one neat, tidy project. And it's really useful to learn about them. If you hover over this, you will get to a resource to kind of learn about them. Can only encourage you to learn it as you go further along your journey. Not something you need to know right from the start, maybe, but as you create projects, RStudio projects can be really helpful. The next thing would be R Markdown. R Markdown is an amazing resource. Actually, these slides that you see here are created in R Markdown. And they're kind of similar to this Google Colab notebook that you just saw, because it allows you to mix text and code and output in one thing, right? So you can do so much stuff with it. It's like, you can't even imagine what you can do with this, right? So what you can do, for example, you can write your thesis in it, right? And I wrote my bachelor and my master's and my PhD thesis, which I'm now going to write, all in R Markdown, right? Because it's really, really useful to just have the code, right? You execute some code, and you output some tables, right? And you output it into a LaTeX format that is also really pleasable to see. and you can output them to PDF, right? So for a thesis, for example, you can create websites, you can create slides. These slides are made in there. What else is there? You can create dashboards and interactive web apps. It's incredible what it can all do. And I can only encourage you to look into this as well. I'm actually going to show it to you real quick, just that you've seen it, right? So you can create a new file in RStudio. Like if you have RStudio on your own, create a new R Markdown object. I just created an R Markdown. New R Markdown, completely, we leave it empty as it is. There's some text here, and you can recognize some of this stuff. Like this is a code chunk where you can execute code. There's also a play button. Works in similar ways, right? We're not going to go into much detail. But like this is a default kind of thing. I really like how our Studio gives you these default things that just work on out of the box. But the important thing is to click on knit. It wants me to save it. Example. Now it combines all the code and text into an HTML document that you can, for example, host on a website, like these slides, for example. And the example is, this is in a Markdown document. When you click knit, here's a data frame, here's some plots, and so on and so on. And you can imagine you can create really nice reports for whatever reason you want to do, right? You can also automate reports with this, which is really nice. What is the slide template here? I use Seringen. So if you want to see the code from my slide, this is actually the code for my slides. And there's a lot of stuff here, right? But this is also our Markdown, right? So really useful. Okay, slides, and we're not going to be too much more. All right, so further resources to learn R. I linked a few in these slides. So you want to highlight some of them. If you prefer to watch YouTube videos, there's really a lot of great introductions. I can recommend Dani Navarro's YouTube channel. She has a lot of great introductions into Dplyr, but also creating art with R, which you can also do. And it's really amazing. So I can recommend you this in particular. I can recommend you the cheat sheets. So this is just a PDF which has a lot of like code shortcuts and so on. Definitely check out those. I can recommend the Tidy Tuesday community. Every Tuesday they create kind of graphs from data sets that they provide, and then there's a whole community, a whole bunch of people get together and code together and post them to Twitter mostly, but I think maybe to other places. And it's a really nice environment to learn how to do data visualization most of the time, but also just to learn R as well. All right. Yeah, I think that's it. So a bit over time. There's not so much time maybe left for Q&A, so I have time, so I don't have to kind of go anytime soon. But let's say, let's do at least 5 to 10 minutes maybe of Q&A, if that's fine. And then there's also enough for me. So you can just ask me anything about like, any kind of questions in general. I'm open to it. You can also find me on Twitter. I'll show you some, at the very end, I'll show you some of my handles and so on. I'm happy to help. Of course, I'm also only human, but reach out to me. I'm really happy to help. Because one thing I'll say is when I learned R, it was really tough, I would say. It wasn't easy for me. And I would have really preferred in the beginning if there was someone that kind of holds my hand a little bit. And I have a strong kind of inner desire to be that kind of person for other people, right? So if I can help you, I do want to help you. Of course, I have to keep it in my own mind and so on. But if there's something, also yeah, definitely feel free to reach out. But don't be. I have to be careful here now because a lot of people are watching, right? But there's also a great R community out there. You can also ask a lot of people here. All right, okay, enough about this stuff. I hope you had fun. That was the most important thing. Yeah, and yeah, again, feel free to any questions. I see a lot of thank yous. I thank you for being here. Actually, have a GIF here as well. lot of happy people that say thank you. Not a lot of questions, which is also okay, of course. I appreciate every thank you, of course. Yeah, have a nice summer.
A lot of thank yous also coming from YouTube. A lot of people are saying thanks. Thanks for the great workshop, great intro to R, and yeah, lots of gratitude. But yeah, thanks so much, Fabio. That was awesome.
Great. Awesome. Okay. Well, if there's I mean, you still have a little bit of time, but if there's no questions, I do want to show you my last slide because there's a GIF on it, and why not? Yeah. Actually, I don't have my handle here, but I'll put my handle here, and then follow me on Twitter. That's where I usually hang out. Yeah. Why are you laughing? Is that not okay to say? Also, follow my meme account.
So there is actually one question.
Yes.
I put it in the chat as well. I tried to respond to it. So one person is interested in how to overcome difficulties updating R within our studio, and do you have any tips of how to do it the easiest or the best way? Yeah, so if you have any suggestions.
Sorry, I didn't hear the dating, or I didn't hear the word.
Updating.
What?
Sorry, updating.
Updating.
Within our studio.
So I mean,
if you have tips about how to do dating in our
no, I was like,
this
okay,
is interesting.
There is also a way for everything. No, I mean, okay, updating. Well, so you mean updating R or R studio? Did I understand correctly, or is that a question?
I think the question was about updating R within our studio.
Oh, I see. So like kind of like via code or something. I see. Updating R in R studio. On top of my head, I don't have a tip, to be honest, because like I'm laughing as well because I haven't done it. I'm still running on the old R version from last February, right? So I would have to Google it. That's the honest answer. And like it's not straightforward. I can tell you that. Like it's not as straightforward as you hope it would be, right? You hope it would just be a button and just update it, right? The other thing, of course, that comes with updating R is that all of your packages will be lost, right? So that's also one of the reasons why I didn't do it. Like all of the packages that you install will not easily translate into the new version. Or like will be available. Sorry, they will typically translate. Like you will typically be able to use them. And R is, I would say, less restricted. Like if you know Python, like the Python versions are somewhat restrictive sometimes, and R is less. So like if a new version comes out, maybe sometimes new things get added, but nothing too crazy. Unless like I just totally missed what kind of weird things happen. But yeah, but rambled here. Sorry, I would hope that answers a bit of the question. Okay. Of course, yeah, there's a lot of people here. But yeah, for me, that's definitely it. And if there's no more questions, I'm happy to end it here.
Can I ask my question verbally? Is that okay?
Yes. So I wasn't checking really the hands. There's so many people in here. Yeah, please ask the question.
Well, first of all, a comment. I think via the help option within RStudio, you can look for updates. Let's say check updates function, and there's the package called install R, which helps updating R within the RStudio framework. But that's neither here nor there. My question is actually within the pipe framework.
Yeah.
If I want to permanently change a data frame or a vector or whatever object I'm working on, do I then have to put the arrow in front of the object and give it a name, whatever? Or if I, let's say, use the penguin data again, pipe all my commands afterwards, will it change the data frame permanently?
Yeah, good question. And I find it often, I actually heard this question often in this context. So just by doing the piping, it won't change the data, right? It only executes the data. It doesn't actually change, or we should rather say, it won't change the objects, of course, right? It will change the data in itself, but it won't change the object. So actually, if you want to save whatever you did in the pipeline, you have to assign it. So you have to put an arrow before the pipeline and assign it to a new object, right? The idea of the pipeline, though, is that you have to do it less often, right? If you would not use a pipe, you would have to do it every step along the way, right? For a pipeline, you do 5 operations, like something that feels like right to you, and then you save it in a new object. I typically, typically how I do it is I use the pipe until I want to do something else with the data set, right? So like I clean it, have the data set, and then maybe I want to do some kind of analysis, right? So I typically don't divide them. Like I tend to create fairly long pipelines, right? But in the end, you always have to assign it to a new object. What I don't want is to have 100 different objects, and I'm not sure like which object was where in which pipeline, right? I want to have very concise kind of actions that I want to take with the data. For example, cleaning, right? So here's all the cleaning stuff, and then I create a data set called penguin clean all at once, right? Not penguin clean this, penguin clean that, penguin clean that, and then I don't know. It clutters a lot of the environment, and the upside of our Tidyverse or Tidy pipes is that it doesn't clutter also the environment. There was a somewhat lengthy answer. Hope that helps.
Thank you.
Okay. All right. I'm not sure if the people are still here. Yeah, thank you for participation.